Good. Sorry about that. Let me reshare my. The host needs to enable sharing for me. So, okay.
You are now.
Okay. So basically, let's actually get back to the assignment. Okay. So let's actually look at the first one. So let me import the necessary modules. Why is it not? Okay. So now the first one, this is how I would try it. So let's actually get the train data first. This is something that you all already started doing. So CSV. Now let's actually look at the data and figure out how to actually get that value. Okay. So this is the data set. What did I ask? I asked the frequently occurring age value. So first of all, we need to filter down on male and female. So this is how you can actually use pandas to filter down on stuff. So this is how you can do it. So you can say, so you can basically put, so basically type the name of the data frame and then put square brackets and then again type the name of the data frame. And then now you get the variable name. So this is the variable name and set it equal to whatever you want. So this is how you can actually filter down on only female. So you see, I actually gotten down female directly without even using if else conditions or anything like that. Okay, let me zoom in. Someone asked me to zoom in. Okay, so without even using if else condition, I actually filtered it down, and this is very important. This is actually called panda slicing. It's actually very useful in these cases. Now, what did they ask? They asked me to get the most frequent age. So let's get that, right? So let's actually do. I have never used this. So select the age one. So now you only have the age of the female passengers. So now I don't know if this will work. Okay, it's already there. See, I got my answer in one line. So this is what I would do. So basically what I did was I filtered down first on the category called sex, which actually tells me female or male. So this is a syntax where you actually filter down or slice into the pandas data frame. So what I did was I used this category. I said this is an if condition. So all I'm saying is if the sex equals female, select the age for me and get the mode. So the mode is nothing but the most frequently occurring value. How do I get male? All I need to do is I need to change this and I got the mode. But there is an issue here. There are 3 modes. And all you need to do is report the higher one, which is 28. So those are the answers. So if anyone has any question here, I can wait, or else I can move on. Okay. So I guess there are no questions here. So just remember that this part. So this panda slicing is actually very useful. It's so quick that I've done the whole thing in just one line. So I'm just going to paste that here. So let me delete this cell. So instead of 24, maybe I'll just say, okay, since I already did my analysis, this is just female, and then this is male. Okay, let's just leave it at that. I'll put this somewhere else. Yeah, I'll just say analysis. Okay, so now that I got that, now let's move to this. Convert this feature of the trained data set into categorical features. This question would require you to first read about categorical features. So did you all understand what categorical features means? Categorical feature is nothing but it's a limited set of categories. So it's basically, this is a good website to actually understand how to deal with categorical data. So in our data set, let's actually look at that once more. So I'll open a code cell and let me get the head. So these are called categorical data. So it's okay. How many categories are there here? It's just 2 categories, male and female. That's one categorical data. A machine learning model cannot accept strings as input. It needs numbers. Even with a subject like NLP, you cannot feed the text directly into the machine learning model. You always need to convert text into numbers. Now, how do you convert it into numbers? One way is just to label it. That's called label encoding. That's called encoding these categorical variables. So what I have mentioned here is this column should have the entry 1, where this column shows female, and where 0 wherever it shows male. So there should be a new column here, additional one more column that's called sex category. In that column, wherever it's male, just put it as 0. Wherever it is female, just put it as 1. You could have done it in so many ways. I've seen some of your solutions. You have done it in different ways. This is my method. So I said lambda function, but you didn't. It's not necessary to do lambda function, but it's pretty easy to do it in lambda function, which I can show it to you. So all I'm going to do is, so df train. So if you look at this carefully, what I'm going to do here is I'm creating, this is how you create new columns. So all you need to say is whatever column name you want, just type that column name here and then assign it to something else. And that should, the value on the right side should be equal to the, so okay, the number of values on the right side should be the same as the size of the data set. So if this data set has 800 rows, there should be 800 values on the right, otherwise it will not accept it. So now I'm going to say dot apply. Let's look at the lambda function. So what's the lambda? So forget the lambda function. What's the default function that you'll write? You're going to say if sex is female, 0, 1. If sex is male, 1. That's all I'm going to write. So I'm going to say lambda x such that take the x value, put 1 if the x value is female, else male. Wait, sorry, I did some mistake. Oh, sorry, yeah, I have to select the column. I forgot. You have to select the column here. Let's actually, before assigning it, let's just print it. So if you see, oh, sorry, I'll 0. Okay, this is 0. Okay, now what happened here is, if you see the, let's actually print them side by side to understand it better. So let's create the actual column. Now let's actually look at the data frame. How is the data frame? Dot head. So if you see, there is a new one. Wherever there is male, you see there's a 0. Wherever there is a female, you see that's a 1. That's because of this lambda function. So what's going on in this? So basically what's going on here is dot apply wherever I have 1, wherever I actually have 1, wherever I actually have female, I'm just replacing that value with 1. Instead of replacing the existing value, I'm just creating a new column. So the new column is called category, and all I'm doing is I'm mapping female to 1 and male to 0. That's the only thing that's happening here. This is the second question. If there are any doubts here, otherwise I'll move on to the other one. So standard scalar. Okay. So why are we doing standard scaling? So we need, okay, there is a reason we need to bring these things to a common scale. So what's going on? Let's read the question. Consider the age and fair columns. These are known as numerical features. Sometimes it is a good idea to scale these features, bring all the numerical features to one scale so that the weights are not biased across the features. In this case, the age and fair seemed, I've explored both the fair and the age columns. Both of them almost seem to be on the same scale already. The age ranges from 10 years to 100 years, and then the fair also is from like $10 to $100 or something. I mean, this happens in the case, let's say you have a salary column and you have an age column. The age is going to be between 1 to 100, but the salary is going to be in hundreds of thousands. So that's a huge imbalance. So you need to be able to basically somehow bring them to one scale so that the weights are not biased. So if the machine learning model is trained, the salary will get a much higher weight, and then your model will make its predictions based on salary. This is just one reason. There are others as well, but essentially sometimes bringing the features to same scale can help improve your model. Sometimes it may not. Which kind of scaling you prefer, that's up to you. You can try multiple things. The most simplest thing is to scale it from mean 0 and standard deviation 1. So all you're doing is you're taking the entire column. Let's say it's an age column. You are mapping the values to some other value in such a way that the mean of everything is 0 and the standard deviation is 1. That is one kind of normalization. How you do that is you just take each value, subtract the mean, and divide it by the standard deviation. That's one of the most simplest ways to actually scale these features. So we can try that. As you guessed it, I will again use lambda functions. So I'll try it for age. You can try it for the other ones. So I'll say dot apply lambda. Now let's see what happens. I'm going to take each value and I'm going to subtract the mean. So which mean should I subtract? I have to subtract the age mean. So I'm going to take minus age dot mean. So I got the mean of the entire age column. Now I'm going to divide it by the standard deviation. How do I do that? Again, you just say tf train age dot st. I think it is called. Is it that? I think so. Okay, yeah. Standard deviation and then mean. Now what happened was each value has been subtracted by the mean and then divided by the standard deviation. But it's getting into zeros. It's getting into negatives. You can just avoid this and use something else called standard scalar. Standard scalar is a package provided by scikit-learn. You just need to import it. All you need to do is from sklearn.preprocessing import standard scalar. Now standard scalar will get your values to be between 0 to 1. So I think it is either at standard scalar or minmax scalar. Let me check. But essentially, this is how you use it. So I'm going to, this is one way. So this is, let me say solution 1. Yeah. Now let me show you another one. Okay. So in this case, I'm going to define my scalar here. Okay. The way you use standard scalar is exactly how you used logistic regression here. If you remember, this is the previous notebook. If you remember, we created an object called logistic regression and we fit it. This is exactly how you need to use standard scalar. So I'm going to say scalar equal to standard scalar. So I've defined my object. Now I'm going to say scalar dot fit transform. I need the age value. So I'm just going to select the age. You shape your data. Okay. I guess, yeah, let me check. I guess I just need to put these brackets here. It will solve that issue. So you need a 2D array. If you remember last time. Okay. Now you see that the data has been scaled to be again between -1 and +1. So if you see this, the same thing happens. So standard scalar is nothing but actually subtracting the mean and divide by standard deviation. If you want to use another scaling method, then all you need to do is go back, import that particular one. It's called minmax scaling. Import that. Let me say solution 3. Okay. So this is one way. Let me say solution 3. So in solution 3, I'm going to say scalar 2. In scalar 2, I'm going to say minmax, and then you just do fit transform again. Okay, time is running out, so I'm going to move. Is it clear until here? Yeah, actually, that's a good point. These packages, they actually take care of that for you. So when I said mean, when so someone asked me, don't you need to drop NA first? So the reason we actually don't need to drop NA here is because when I say dot mean, it's automatically understood that it's going to avoid the NA values and take the mean of the rest of the values. That's built into these functions. That's a good advantage of these things. That's why I didn't drop it. And that's why it actually worked. I hope that clears the question. Yeah, it can. So someone asked, does the normalize equal to true take care of it? It can take care of it, yes. But these are pre-processing steps that we still do in hopes that our model improves its performance. So now implement the, okay, I'll take 5 more minutes now. Implement the logistic function. Actually, this is a question.
Yes, can you just scroll up to the second code again? The last solution, I didn't capture that.
Oh, sorry. Okay, so the last solution is it's the exact same thing. It's just min-max scalar. So again, I'm going to say scalar underscore 2 dot scalar underscore 2 dot fit transform, and then I'm going to put the same exact thing. There's no difference. I'm just going to choose the exact same thing. It's just that the function name has changed. So if I run this, let me comment these things. So if I run this, you see the values are actually been scaled between 0 and 1. So this is more agreeable because age cannot be negative. So I feel that maybe my intuition is that maybe it's better to use this, but you never know, anything can work. So those are the 3 solutions. So standard scalar. So essentially this is standard scalar. If I show you the documentation, you see this is what they're doing. X minus U by S. U is the mean, S is the standard deviation. This is exactly what's going on inside standard deviation. Minus mean divided by standard deviation. Min-max scalar is another, it's subtracting the minimum value and dividing by the max minus. You can always go over these documentations. They have the entire formula written inside. So I hope this is clear now. Okay.
Yes, thank you.
So this is actually sigmoid, not logistic. I already shared a document on Slack, which actually talks about the difference between sigmoid and logistic function. So how do you implement it? What is the sigmoid function? If you looked at the previous week's slides, it's 1 by 1 plus e power minus x. So that's all you need to do. What you need to do is, how do you get exponential first? How do you even take exponentials? It's available in the math module or NumPy module. So you first import the NumPy module at the top. Now get to the question, and then here, sorry. Oh God, this is very big. Okay. Now here, let's define our function. Let's call it my logic. Okay, my sigmoid. Okay, let's call it logic function. There are so many names for this. The value is x. All I need to do here is result equals. I'm just going to type in the formula exactly as it is. 1 plus exponential minus x. And I'm going to return the result. So, okay. Yeah, ignore this one. So now let's actually call it my logic function. Let's say 1. So that's what happened. 1 by 1 plus exponential e power minus 1. That's what happened inside. So this is how you implement it.
Hey, Ani, quick question on that logic function. I didn't put np.exponent. I think I just put 1 plus exponent.
So maybe there is a function called exponent, I guess.
And I got the same result.
Okay, I don't know how you got that. Did you import something?
Yeah, I think I import math.
Okay, yeah. You can use in NumPy or math, anyone. Like I use NumPy, but math also has an exponent, but it doesn't matter. All as long as you get the same result. Okay. I'll just take one question. Someone asked when to use min-max, when to use standard scalar. There is no rule. There is really no rule. It really depends on. You can try out both, whichever works out best. But scaling is all. The main idea is that scaling is always a good idea. It depends on how you want to scale it. If some of the other mentors have a better answer, maybe they can give it to you in the chat. But otherwise, there's no real rule to which one to apply. when you use minmax in test data set. Okay. I'll actually tell you how to actually use it in the test data set properly when we get to today's lecture. So the last one is the logistic regression. This is exactly the same thing that you have to do. So the reason I asked you to implement it again, because I actually, so you, until after you attempted question 1, 2, 3, 4, you would have created at least 2, 3 features. My point was you actually use those new features and do the exact same thing that you did here. Logistic regression, dot fit, and then dot predict, and then get the classification report. You should have seen some improvement in the model performance. That was the whole point of this assignment. We are going to do the same thing today. You all are maybe already prepared, but we are going to go over the slides now and then get to the notebook. In the meantime, in these next 2 minutes, I'll actually share the notebook with you all. Just give me 1 second. So today's session is going to be a little bit more on the coding side, and let's also try to make it as interactive as possible, because it would be good if you can actually do it yourself, like along with me, because these things actually, if you type them, then you'll actually really understand. So I'm just about in 1 minute, I'm just going to share it in the Google Drive so that you can actually load it. So in the notebook, you'll notice that I have actually left few blanks. There is a reason for that, so that I can get some answers from you. That's the only reason I've left some of them blank, but otherwise, yeah. So, the same visual. We'll do a lot of visualizations today, and you will do much more later than what we have done today. But otherwise, yeah, I've just uploaded it. You can go and grab it from there. Let's actually get to the presentation for today. So, okay. So I hope the assignment is clear and you all have actually done a lot of research. Yeah, you all have been posting a lot of questions, and it's good that you're actually getting excited about this subject. Let's actually start today's topic. So we are going to start with what is exploratory data analysis. Why do we need to do it? First of all, why can't I just say model.fit and get it done with? And the next thing is how to actually do it. How do I even think about what to visualize? I think that's a much more important question to answer. What do I even think about? Why should I even visualize? What is my motivation? Let me share. Let me put it in the presentation mode. Okay. So, and then the next one is features. We'll actually go over feature engineering, why is it important, and I'll share a document later which is much more detailed on how to actually do feature engineering along with the packages that you can use. And then yeah, the common package is available for feature engineering, and then some handcrafted domain-based features. Let's say you're working in the gaming industry. You have some data set. How do you build features? If you are someone who plays lots of video games, or you have some knowledge about the game, then you actually know something that others don't. They are called subject matter experts. We'll get into that in the end, and then we'll start practicing. So we don't have many slides today because I wanted to focus on the actual code part, but whatever I have in the slides is actually a lot of information to cover. So let's actually see, just as the title says, exploratory data analysis is all about exploring our data. What is there inside? Like when you look at the data set, all you see is a bunch of columns and a bunch of numbers, strings, names, etc. How do you interpret that? How do you know what's going on inside? The purpose of visualizing the data is just to understand your data. What are the different relationships among the features? How are they related to my let's say in our case where we are using the Titanic data set, how are the different features related to the survival rate? Is there any relationship that I can explore and then I can use in my features, which will actually maybe improve my model? Those are the kinds of questions that you can ask. So this is how you can do visualization. So you can get you can visualize the basically the final our class labels. So or the label or the feature, the column that we actually want to predict, that's survived or not. So I'm just checking the ratios. And then the other one is to compare the actual features against survived. So I want to see how they are related. So someone actually posted in the group saying that women and children survived and men actually didn't. It is so clearly evident from this graph. We will explore it much more later. And then there are something called violent plots. So yeah, there are multiple ways in which you can actually explore the data. It really depends on asking the right questions. So let's actually try and ask some questions. So okay, once again, exploring the data is all about creating a story out of your data. So without machine learning, without actually doing any machine learning, you can answer a lot of different questions just by visualizing the data, just by looking at your data and histograms and scatter plots and box plots. Just by looking at them, you can arrive at so many conclusions, and they will actually solve a lot of your problems before jumping straight to machine learning. What are the kinds of questions you can ask? I've given a few examples. So how many people survived and didn't survive? That's the first basic question that comes to my mind. And then what is P class? Like, I don't understand what is P class. So maybe I'll explore that and find out something. How is age related to survival rate? Did younger people survive or elder people survive? Who was the most one who survived the most? Like this, this is a small exercise now. Can you come up with new questions right now? You can type it in the chat or you can speak up. What kind of questions would you like to actually explore? You can just like these. Does anything come to your mind? You can just type it in the chat. So this is how you actually do exploratory data analysis. You have to ask the right questions and then dig into the data to answer these questions. So you can, if anyone has any idea. Does fair price affect survival rate? Yeah, that's a good question. So obviously, I would assume that people who paid higher would have been in the top bunk of the ship, and then since the bottom bunk of the ship might have been flooded with water, but the top bunk people were easily able to escape. So that's one reason. Yeah, so this is how you actually do. This is how you actually think about what to even explore in data. Ratio between male female survivability. Yes, those are the kinds of questions that you actually have to basically address in exploratory data analysis. Yeah, what is SIB, SP, and parts? Actually, honestly, even I haven't really seen that. Let's explore this today. So let's actually see what those things are. So there's a cabin number and all those things. So okay. So basically, just give me 1 minute. Sorry. Okay, I just have to get my chart. Okay, so let's actually see what is dimensionality reduction. So now that we've answered some questions, now that we've actually gone through all these, so now that we've actually understood how to even think about how to explore the data, one problem that occurs when you're exploring data is you have so many columns here. Like in our case, I guess we have around 11 columns or something. So it's very easy to visualize 2D or 3D data. It's really very easy to I can actually visualize 3D data or 2D data in my head. I know how a scatter plot looks. I know how a histogram looks, and maybe I can even visualize a 3-dimensional space. But when it gets to a 4th dimension or 5th dimension, or even an n dimension more than 3, we are just incapable of doing that. Can you right now imagine how 4 dimensions would look like? Like how do you even visualize 4 dimensions? It's actually very difficult to do it. Maybe people are coming up with ways, and I guess in physics some people say time is the 4th dimension, but essentially it's very hard to visualize such high dimensional data. The dimension actually comes from your columns. We have 11 columns. That means our data set is 11 dimensional. So it has 11 features, 11 different dimensions. Each one carries some meaning behind it. Each data point actually carries some meaning behind it. Dimensionality reduction techniques are a set of techniques that actually help you reduce the huge set of features. Like let's say you have 50 dimensions. Let's say you have, okay, if you take an image, let's say you take an image. An image has so many dimensions, it's actually made up of pixels. So the number of dimensions for a single image is basically the height multiplied by the width. So let's take an 800 by 600 image. So if the image size is 800 by 600, you'll actually have 800 into 600 columns. So that's so big. I mean, you're expanding the entire pixel. Like each column in your data point for a single image actually represents the pixel value. So the first pixel value, second pixel value, third pixel value, like that, you have to expand it 800 to 600 times. It's so ridiculous to explore such high dimensions. Dimensionality reduction techniques actually help you visualize such high dimensions in 2D or 3D. One more reason why you need to get to dimensionality reduction techniques is because to address something called curse of dimensionality. This might sound like a very trendy curse, or might sound like a fancy word, but this is actually there. It's there in few textbooks, and also I've posted a video in the slides in the notes. You can check out that video. Basically, if let's say you have 50 dimensions and you only have 100 data points or 20 data points, 20 rows and 50 columns, your model will perform very, very poorly. The reason is having more columns and less rows is the curse of dimensionality. It actually deteriorates the model's performance. You always need to make sure that the number of columns that you have are not so huge that it's even bigger than the number of rows. So what is the curse of dimensionality? Why does this happen? Why does the model not perform well if you have higher dimensions? Like it's always good, right? Why can't I have more features? If I have more features, obviously the model should perform well, but that's not just the case. Like there is a reason that why if you have higher and higher dimensions, the model performance might not be that great. Keep in mind, when I say higher and higher dimensions, compare it to the number of rows. If you just have 100 rows and you keep increasing the features to 200, 300, or 500, the model doesn't perform that well. One reason is it's kind of the model is being overfit. The other reason is this curse of dimensionality, which I am actually going to explain using few graphs. So let me minimize this screen. So it's just going to take 3 minutes to explain this, but otherwise, let me show you. Okay, so what is, let me draw this. Okay, so here, I think you all can see my marker as well. Okay, so let me, sorry, scratch out this. I don't know how to erase. Just a minute. Okay, so basically, okay, so let's actually start with one dimension. So what is one dimension? One dimension is just one line. So one dimension, this is 1D. I'm going to draw 1D here first. So this is 1D. So one dimension is just a line. Now imagine that on the line you have few data points. So you have plus, 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 minus, and then minus, minus. So these are two classes. Assume that these are two classes. There is a class called positive, and then there is a class called negative. So class plus, and then class negative. So assume that these are two classes. In one-dimensional, this is how they can be represented. There is no y-axis anymore. It's just one axis, and that's the one-dimensional axis that I'm showing here. So this is the dimension. So there's just one dimension. I'm trying to visualize my data in one dimension. This is what happens. There is no, basically, it's not a 2D space. The points can't come here. I mean, okay, I might have drawn it above, but essentially the points are all lying on this line. Maybe I haven't drawn it properly, but essentially the points actually cannot float here. So all the points are actually on this line because there's one dimension. Now, can you all come up with a classifier? How can I classify these two things? Where is the decision boundary here? You can give the answer in the chat. There's a clear-cut decision boundary that I can see right now. How do I separate these two classes? How do I separate them into positive and negative? So I need to draw a line. Where do I draw a line? No, not by sign. The sign are the two classes. Okay, assume they are the same colors. Just a line through the middle. Yeah, exactly. That's the answer I was looking for. So this is the decision boundary. So all my machine learning model needs to do is just draw a line here, and that's it. Whatever comes on the left is positive, whatever comes on the right is negative. So it is so easy to do it in one dimension. Now let's move on to 2D. So the same points, let's look at the 2D space. So 2D space involves x-axis and y-axis. So this is x-axis, and then this is y-axis. So if I try to plot this one here, there is only one dimension. If I try to expand it to 2 dimensions, what happens is, this is what happens. So they were on a line, and now they are going to get scattered in this way. So maybe pluses are going to come here, maybe minus is going to come here, some minus here, some minus here, minus, some minus here, something. Maybe randomly I'm just throwing out these points. It's just that I've expanded them from the line to 2D space. So let me divide this into a grid. So assume that this is a big grid. Might get slightly messy, but assume that this is a big grid. So they are thrown into this 2D space. So from 1D, so let me clearly write this. This is a decision boundary. Okay. So now in the 2D, from 1D, they've actually jumped to 2D space. Now, the number of data points are the same. They are exactly the same. The number of data points did not increase. But what happened is they just got expanded to 2 dimensions. Now, if you notice, there are actually some blank spots here. This one is blank, this is blank, this is blank, this is blank, this is also blank. There's nothing going on here. What does the model do? The model is confused. Now, the model actually knows that when it scans this point, it clearly knows it's positive because it's coming in this area. But what about this? What about this one? What about this one? This is all blank. I don't know what to do here. Do I give minus or do I give plus? So already the curse of dimensionality is kicking in. Let's actually take it to 3D. So this is 2D. Let's actually take it to 3D. So 3D, this is how it looks. So I'll try to do my best. So axis 1, axis 2, and then axis 3. So when I say axis, I mean features. So this is just represented by one feature, 1 dimension, 1 feature, 2 dimension, 2 features, 3 dimension, 3 features. So maybe this is x1, x2, and this is x3. Now, same points, again, I'm going to scatter them somewhere, plus, minus, minus, plus, somewhere. It's going to get scattered somewhere. I don't know where, like somewhere it's going to get scattered. Now, see that you have so many gaps here. Imagine how many gaps you will have here. It's 3D space. 2D space itself had so many things because it's a square. 3D space is actually a cube. So I'll try to draw the cube also here. So 3D space is actually a cube. Imagine how many empty gaps you'll actually have here. There's so much empty gaps. The model doesn't even know what to do over there. Imagine now taking it to 4, 5, 6, 7, 100 dimensions. The gaps, that model doesn't know what to do in those gaps. This is the curse of dimensionality. This is what it means to, that is why the model might not be able to perform that well. The same explanation is provided by the person I said I gave in the video, please look at it. But essentially, this is the best explanation that I found for myself that I actually understood very well. I hope you also understood this concept of curse of dimensionality. Why the model performance deteriorates when you actually increase the number of features. Are there any questions? I can move forward. Okay. So let's move on. So this is so dimensionality reduction techniques. Effectively, what it does is it does the reverse. So it goes from here to here. This is what dimensionality reduction does. So I take some higher dimension. It goes from ND. It comes down to 1D. So this is dimensionality reduction technique. This N can be 2, 3, 4, or anything. It can keep going on. From higher dimension, if I want to basically visualize my data in lower dimension, this is what I'll do. How do you do it? There are multiple techniques. Principal component analysis, PCA is one popular technique. LDA is another. LLE, isomap. These are all different techniques that are pure math techniques that actually use the concepts of eigenvalues and eigenvectors to actually project the data and get it back to lower dimensions. I won't go too much into depth in PCA today, because it's a whole new subject and it takes a lot of time to actually cover PCA itself. I can cover that much later, but essentially try understand that there are techniques that allow you to do this, and I will post the resources in virtually for this specific thing. So as I've been posting resources for everything, I'll post resources for this one as well. How do you actually do dimensionality reduction? So okay, where is the image? Okay, yeah, okay. Our baby Yoda is back. Okay, let's look at feature engineering. So now let's actually see what's feature engineering. What is feature engineering? So feature is nothing. By now, I think you all understood that features are nothing but your columns, the data, your what actually the okay. How do you describe your data? Those are your features. Features are nothing but the characteristics that define your data. For example, for a human being like ourselves, height, weight, age, or for an animal, both of us are defined by these features. Let's take a book, just a piece of book. Number of pages, the color, whether it's paperback or hardcover. These are the features that describe a book. So features are nothing but the features that actually define the data. As I said, as I explained, curse of dimensionality is one reason. You need to do dimensionality reduction. There are so many other reasons to improve the model's performance, just to add more features. So okay, now let's actually this is another exercise. I am going to ask you to come up with features. Can put it in the chat, or maybe you can speak up. What are the features that you think make up Baby Yoda? What are the features? How do I describe it? How do I describe the features of this little creature over here? Skin colors. Okay, so actually skin color is a good one. So let me write down skin color. But how do I encode face shape? Eye color. Okay, I need something to quantify. I actually need something to quantify. Size. Okay, that's great. Size. Fingers. Ear size. Okay, ear size. Fingers. But what fingers? Oh, you mean the number of fingers? Okay, that is good. But okay, let's say you said wrinkles. How do I quantify wrinkles? How do I actually quantify that? I need to quantify something. Length. Okay, yeah, height, length. I can see those. Location of the eyes and ears. Okay, yeah, okay. I think we had enough of Baby Yoda. We have dissected Baby Yoda a lot. So this is good. Weight and height. So those are all the features that describe this one. But there are techniques. The most popularly used algorithm for extracting features out of images is called convolutional neural networks. We will discuss that later. But CNNs are actually very good in extracting features. So whatever you just said, weight, skin color, eye color, number of wrinkles, maybe the number of wrinkles is a very funny one. Whoever said that, the number of fingers. So all these features are somehow extracted by convolutional neural networks using lots and lots of complex calculations. They actually allow us to extract features. So the actual features that are extracted from an image are something like this. So these edges, if you notice these edges, so this edge is what makes up Baby Yoda. So this, whatever I'm just drawing here, this might make up Baby Yoda. So this edge, then this one, these edges. So this is what CNN algorithm actually captures. It captures in image processing. These are actually very important. So the edges. So you all said wrinkle. The way an image processing algorithm works is it actually extracts these edges. It knows that there are some lines over here, and then this ball over here, and then these fingers, the shapes, the edges of these ones, and then those Sobel edge detection, exactly. So I have used that. Those are one set of features that image processing algorithms do. Now this is a very hard one. I'm not sure how many of you are going to get it or be able to think about it. This is a sample. So this is an image. Now let's look at a text data. You will actually explore this in the NLP project, but this is a sample review where they say the earphones that I purchased were working very well at first, but later stopped working completely. What are the features that make up this text data? Can you come up with features? Number of verbs. Okay, that's great. Language. Yeah, okay, language is good. Length of the words. Yeah, so length of words, language, length of words, and then someone said number of verbs. You all are very good, actually. You already know a lot of NLP. Letter counts, number of common words, exactly. So these are all sentiment. That's good, actually. Sentiment, whether it's an adjective, basically. Okay, those are called POS tags. You will learn about it later. Those are called POS tags. That's good. So these are all the features that make up the text data. So these are all the features. Then there is something called NERs, named entities. You can explore it later, but essentially now actually I think you all are getting the idea. What are features? Features are nothing but what describe the data. When you talked about images, you are talking about the edges of the image, the size of whatever is there in the image, the color of whatever is there in the image. Those are the things that make up an image. Text data, you actually not naturally, you all came up with number of positive, negative words, sentiment, number of verbs, common words, letter counts. So these are all the features that actually make up the data. I hope now that you actually got an idea of what it means to actually do feature engineering. These are the features that make up the data. So, okay. Now let's actually look at the different methods of feature engineering. So basically, in feature engineering, there is something called, okay, there are few different categories of feature engineering. Feature extraction, feature selection, and then domain specific features. I mean, it's not limited to these, but I have limited to them because these are the most important ones and the most commonly encountered feature engineering techniques. So let me draw it here. Okay. So this is our data. It's in the form of a table. So we have multiple rows, blah, 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 and then we have columns. So these are some column A, column B, column C, D, E. Okay. Now, feature extraction, what it does is it actually derives or creates new features from existing features. So maybe after feature extraction, your new column might look like this. You will have again the same, like you will have the same number of rows, but the number of columns can actually be new. Maybe this column is called A square. Maybe this column is C multiplied by D, or this column is totally new. I don't even know what that column is. It's maybe Z. This is a complete combination. It's like a function of A, B, C, D, and all the columns combined together. So this function might actually be PCA, dimensionality reduction techniques, LDA, or it can be, I don't know, in case of text, it can be TF, IDF, it can be anything. Like basically, feature extraction, the concept of feature extraction is you take the data, this is the original data set. So this is the original data set. You are deriving new things. You are basically extracting something new from the existing ones. So the new ones might not actually make sense. The new ones actually might be something very new. You might not be able to interpret them. That's what PCA does for you. Actually, PCA maps higher dimensions to lower dimensional space using techniques called eigenvalues and eigenvectors, the new values on which it maps the data, actually we don't know what that is. Actually we can't interpret that. It's just a dimension, it's just an eigenvector, it's just a new dimension. One hot encoding, these are other. So if you remember, we had male, and then we had female, and then we had female in our data set. One hot encoding, the way it transforms is, this is what it does. So after one hot encoding, this is how it transforms. So there is a new column called female and a new column called male. Since this row says male, one hot encoding makes this 0, 1, because this 1 stands for male and 0 stands for there is no female. So because there is a female here, the way one hot encoding works is it transforms the value, the categorical value of female into 1, 0. And then the next row says female, so again it says 1, 0. So this is what one hot encoding does. This is the feature extraction technique. So you are basically just creating, changing the categorical to numerical values. So what is feature selection? Feature selection means you are actually just selecting a subset. So I'm going to use some kind of statistical tests, and finally I'm going to end up with, let's say, A, D, F. Maybe these are the best columns that I have based on the statistical tests that I've conducted. That's what feature selection does. There are libraries. These are they are called select k-best and recursive feature elimination. These are 2 techniques, but there are more. They are provided by scikit-learn, and at least you will start learning about how feature selection works. Feature selection is basically the exact original data set. You just get a subset. You just get a subset of it. Feature extraction, you transform the data and get new things. That's what feature extraction does. So feature extraction, the benefit is, this is okay. Someone asked what are the benefits of feature extraction. So this one, I'm still stuck with the same features. You never know. A combination of features or some kind of newly generated features are actually much better than the subset. That's one advantage of feature extraction. You might get something new, something totally new. Maybe you might not know what that is. You might not be able to interpret it, but those new features, the combination of features or the transformed features, the new features actually might help you better than the existing features. That's one reason. It's just like a hybrid. It's just like a hybrid of the existing features. One thing to keep in mind is that PCI is originally meant for visualization and dimensionality reduction, but you may use it for feature engineering. Let's say you have these features. PCA, it results in 1, 2, 3, 4 columns after PCA. Finally, you feed this to model and you get some results. So you can do this, but otherwise, essentially, it was meant as a data visualization technique to actually get results. So someone asked, Jonathan asked the question, is pandas get dummies one hot encoding? Yeah, it's sort of like a one hot encoding, but actually, yeah, it is a one hot encoding. So there are different kinds of encodings. I could have also, if you look at this, I could have also done this. Instead of creating 2 columns, I could have just created 1 column as I've just shown you in the assignment solution, and just say 0, 1, 0, 1, 0, 0. That's also possible. That's still encoding. That's called I think it's called label encoding. So that's another way. So what I wanted to say is feature extraction is basically generates new features, and then feature selection select a subset. Now domain knowledge specific features. How do you get these things? So this is something, there are few people, okay, it's not a job title, but essentially subject matter experts are people who basically have a good knowledge about that subject. Let's say you are dealing, you are in the health sector. You are in some company that does AI in the health industry. Let's say you are working on a data set that maybe takes the, okay, I think I've seen this. So somebody has built a model where they have taken the X-rays, done image processing, and then try to predict the likelihood of getting COVID or not. This has been developed by someone, and actually been used in some of the models. I think there's a Kaggle challenge somewhere that uses X-rays to actually detect some kind of disease within the person. You will just use a CNN model, you'll just extract the features, you'll get your results, and you'll get 99% accuracy. Everyone's happy. But what if actually it doesn't perform that well? Sometimes you might need a domain expert. A domain expert is someone who's actually familiar with X-rays, who actually knows what's going on in an X-ray and who can actually interpret an actual physical X-ray. When you listen to them, they might actually come up with some new features that can actually help you improve your model. That's called domain knowledge specific features, and that's very hard. Oh, that is there. Yeah. Noha just said that is their latest competition, 100K. Yeah. So essentially that X-ray COVID thing is actually a good example here. Let's say if some of your friends, when you attempt the Kaggle challenge, if one of your friends is actually doing their medicine and starting to become a doctor, you can actually go and ask them, what is it that you understand from X-rays? You could actually code whatever she or he tells you in their own language. That's how you actually generate new features. And it might actually help. The model can actually learn something new outside deep learning automatically generated features. So last thing that I'm going to cover today in the slides is dealing with data. So I think you've already seen it in the assignment. We are going to look at it today in the notebook as well. Machine learning algorithm, this is very important. So machine learning algorithm can accept numbers. You can't feed it strings or integers the strings or text data as it is. Anyone have any question? Okay. So now how do we convert our data to numerical data? So the first thing is you will see this is the most common kind of data that you see. This is
Something like that, yeah.
几点钟啊？
I think if you all can mute yourself. Thank you.
你们两个
Okay.
都是这个样子。
Really? We were just done eating though, so
什么？我们这一挺
we were just
Maybe
finished
someone
eating,
from the
right?
organizers
You
to
just
just
finished
mute
eating.
everybody. They can do that on their end.
Okay. Yeah. So now let's actually look at the numerical. I hope I didn't mute myself. Okay. Let's actually look at the numerical data. So numerical data, now what happens is it's already numbers, right? You can't do much to that. All you can do is like make sure you balance out these points like this. This is called scaling. So these are the kinds of things that you can do. Categorical data is something that you just seen. Gender, t-shirt size, small, medium, large, or weather conditions. Okay, this is weather condition. It's not the actual temperature. So weather condition actually means sunny or rainy, maybe humid. This is a limited set of categories that you have, or just hot. So cold. So these are all the weather conditions. So this is like categorical data. The way you can deal with this is I just showed you one hot encoding, convert them into numbers. So can basically encode them like this 1, 2, 3. I can just map them in this way. So or I can do all sorts of things. So that's essentially you have to do something to make these into numbers. Last thing is text data. Free text data is so commonly available these days. Emails, chats, survey responses, chats from chatbots, and there's so much. All these scientific research papers, articles, blogs. There's so much text data. How do you feed that to machine learning model, and how do you actually make it understand text? You will actually learn all this in the NLP project in the later weeks, but essentially you need to vectorize them. What I mean by vectorizing is converting the text to numbers. This is what vectorizing means. So essentially what happens is you use techniques such as word embeddings or a TF-IDF count vectorizer. These are different techniques that you will learn later when you actually start the NLP project. This is another commonly used data to deal with. There might be other different kinds of data, but I think I've covered most of it, at least, that you will actually see out there. So I think, I think I've covered it pretty quickly today. I hope you all understood very well what is feature engineering and why we really need it and what's curse of dimensionality. And I would really urge you to watch that video, which is very interesting. And then Now I think it's good to take about 10 minutes break to start. I'll be here. I'll answer any questions you have. It's 4:04 for me Eastern time. Let's come back at 4:15 exactly. So yeah, I'll be here, and in the meantime you can stretch, exercise, and then make sure you're actually uploaded the notebook and be ready. I'll stop sharing my screen. I'll be here if you have any questions.
Can I ask a question, Annie?
Yeah, please go ahead.
This is pertaining to the way I was doing the homework for last week.
Okay.
If I were to just to generalize that question, so if I were to just to subset a set of a data set and name it a different variable, and then I operate on it, but I don't make a true copy of it, shouldn't all the changes that I made on that new data set,
Oh, you want to make a new copy?
I know I made a new I renamed a subset of data of an original data set.
Okay.
Let's say the data frame subset.
Okay.
I modified the age on that data frame subset, but I didn't make a true copy. So should I expect to see the new modifications in the original data set?
How did you make a copy?
I just renamed it to a variable. I just say select.
So is this what you
insert
did?
into-
So new auto df train something here. Is it like this?
Yeah.
Some calculation here you did, right?
Yeah, say age less
Yeah.
than age
Okay.
less than 20, or NaN is in the age, or something like that.
Okay. Yeah. So basically this will affect it. Now, whatever changes you make here, the original data will get affected. This happened to me so many times.
But I didn't see it this time on mine, so I was expecting it to happen, so I could just skip one step.
So did you say dot copy in the end?
No,
right?
I didn't. No.
Why don't we try it? Okay. So let's say df new df underscore train. Okay, I'm just going to say this. Now let's see df underscore new. Okay, so df underscore new. Okay, I have everything. What do you want me to change? Okay, let's just do the age
Let's pick
thing.
up all the ages with NaN in it.
Okay, so okay, let's pick the we have to actually do some calculation on it first. I'm going to subtract 10 from all the ages. That's just a random calculation that I picked right now. So we have to do some kind of calculation on it. So lambda x such that x minus 10. Okay, let me save this. What happened is, okay, I know this was 22, so it became 12. Let's check. So it changed, right? So even df.train changed.
Oh yeah.
So it does change, yes. Unless you say dot copy. So this happened to me few times, and I actually I didn't even understand what's going on. Why is my original data changing? I actually had no clue what was going on. I was actually very surprised when this happened. Then I understood that I didn't do this dot copy. So it's actually very risky to do this. Like if you want to keep your original data frame as it is and make some changes in a new data frame, don't do it in this way. Always use dot copy.
Okay.
So essentially, I think, okay, what I think is actually going on is, if you know the concept of pointers in C++, I think essentially something like that is going on here. What happens is, I didn't actually create, okay, a reference to the original data frame has been created. That's what happened. In C++, there are two concepts called references and pointers. What happens is, I actually didn't create a copy. I created a reference to this data frame. So this is essentially a reference to df.train. So whatever changes I make here are going to be reflected here because of this equal to sign. That's what happens here. This comes from C++, references and pointers. I think so. It's essentially the same thing. Whatever change you make here on df new, it's going to be reflected in df train.
Okay. So I also got another weird message which I couldn't. So I got a settings with copy warning when I did something like that.
Okay, you can avoid warnings. It's okay. There is a meme about that as well. Like, people start laughing if you say anything to do with warning, but essentially it means that you have tried to copy something on the, you have basically tried to replace this existing value with something else. I think that's what you did.
Yeah,
That's what I'm guessing.
Replaced the value on the subsetted data frame.
Yes.
And I expected to see it in the other one, but I didn't actually.
Yeah, I mean, that's, yeah, these are all the things that you need to start playing around with to understand really what's going on pandas data frame. But warning is fine. It's okay.
Thanks.
Dot copy. So okay, this is what dot copy means. Let me. It's the entire copy. Like it's new. Okay, let me say new 2 df train dot copy. Now what happened is, let me change it to 2. Let's check df train. It's 12. Let's actually check new. It was the same thing as before. It actually retained 2. See, I reduced it further by 10. So this is what copy means. It's a complete copy of the entire data frame, but totally distinct from the original one. Nothing is going to affect the first one. Exactly. Okay. Okay. That is what I was talking about. C++ pointers and references. So their memory address would be different. That's why they are not getting affected. So one pointer is in case of the original one without copy, one pointer is pointing to, basically it's the same pointer pointing to both, or something is going on there. So basically, in this case, there are actually two different memory. They're actually pointing to two different things. So it's independently changing. But here, what happens is, it's just like a C++ pointer or reference. If one changes, the other one automatically will change. That's what happened here.
Yeah. Thanks.
Yeah, Robert was asking that question and answering his one as well. Get 3 more minutes. Let me set this. So today you'll see all fancy histograms and scatter plots and bar plots. So it's going to be a colorful one.
Hello? Hello? Oh no.
Does anyone have any question?
I have a question. Can you hear me?
Yeah.
Okay. So I am actually working on a random project that's like kind of related to machine learning. For like is it PyTorch that we're using, or what was it? It is PyTorch. Can you have a image like a array as the output, like a full array, or would you have to do that a little bit differently? I don't know.
Sorry, could you repeat the question? Sorry.
Using what we're using, if we were going to use like a neural network,
Okay.
could you have like, for example, like an image in as the input and then like an image out as the output? That work?
Yeah. So, okay. Oh, you mean you're sending the image into the neural network, transforming it, and then you want to see another image as output?
Yes.
Okay. Yeah, it is possible. So there is so actually matplotlib can do that for you. I think it's called imshow. I think that the name of that function is imshow. So plt.im, if I'm not wrong. Okay, wait. Im. Okay, yeah, this one. So
Okay.
you use this imshow. Inside you need to feed the whole matrix, the pixels, all the pixel values as a big data frame, and you just get your image.
Okay.
Yeah, this so this x value, if you see here, x, the image data, that's what you need. So the array, the actual array. Yeah.
Okay.
That's,
Thank you.
okay. Yeah, actually, okay, it does sound a lot like MATLAB because I think Matplotlib is essentially has been built on the basis of that or something. It has a relation to this one. One minute. Both are actually, yeah, Matplotlib is a visualization library, while MATLAB no, somewhere I have seen that there is a relation between the two, that it's used for something, but essentially yeah, it does sound like MATLAB. But Matplotlib is a very good library. There are so many visualizations available within this, and can definitely do a lot with this thing. Seaborn is another one built on top of Matplotlib, and it actually, I felt, I don't know, personally for me, Seaborn was much more easy to use, and the visualizations actually look much better. There is something else called Plotly, Plotly. That's also another good visualization tool. Okay, it's 4:17, so let's start. I hope everyone's back. So make sure you have the notebook here. I'll just wait for 1 more minute. Just make sure you have all the notebook ready to basically upload the data and make sure that you actually have everything ready so that you're not stuck somewhere when I'm actually going through these things. Where can we find the notebook? It's the Google Drive link. If some of the organizers can share it. It's the maybe if someone is sharing it. Okay. So the Google Drive link. Let me. Where is that? It's basically been posted on the chat. It's right here. Okay. Thank you for sharing that link. Okay. So the data set is exactly the same every week until week 6. We are always going to use the Titanic train set and nothing else. So we are always going to use that because we need to develop much more complicated algorithms and see improvement on the same data set. Finally, at the end of this course, I hope that you all will make your submissions to the Kaggle competition and at least one of you will emerge as a victorious person. I hope, based on because the challenge keeps going on forever. So you can, whatever you learn from this course, you can definitely make a Kaggle submission. Okay, let's get started. I hope everyone's loaded their notebook and also the data set. I'll be moving on. So import the libraries at the beginning. We'll be using pandas, numpy, seaborn, and as usual, logistic regression and then the classification report. The only thing you'll be seeing more of is, I can't access the link. Okay, let me share this drive. Let me just share this. Yeah, this is the ML Bootcamp link. This is the drive link. I think if you just click this, you'll directly go to ML Bootcamp, and then you just go to week 3 and get everything from there. So you have the notebook here and the slides here. Okay, so okay, now let's move on. Let's actually get the import the data, and then let's view these things. So we have P class, we have survive, we have passenger ID, we have name, we have so many things. Someone actually gave the definition of SIB-SP. Let me check that. So I think it's a number of siblings. Yeah, SIB-SP stands for number of siblings, spouses aboard, and then number of parents, children aboard. So let me paste that once more. Thank you, Aaron, for posting that. I've posted it once more. So let's actually start exploring them one by one. So the first thing that comes to my mind is just say, you can say yes or no in the chat. Does name have anything to do with the survival rate? Does a person's name have anything to do with the survival rate? Yeah, you can say yes or no. Does a person's name really determine? So obviously, okay, maybe I feel 90% confident that a person's name has nothing to do with their thing. Okay, the title could, maybe, yeah, okay, actually that might be a good answer. Maybe the title can, because let's say the title is doctor. Obviously, okay, I was going to say the same thing. Doctor, they might actually have more money, and then they might get a higher class, and that's good. But essentially the name itself, the whole name might actually not be that relevant, but the title can. So now that that's out of the way, what is our actual class that we are actually trying to predict? What are we actually trying to do here? We are trying to predict the survival rate here. By survival rate, I mean who survived and who didn't survive. So basically the survived column is finally the exact, the survived column is actually the one that we are actually trying to predict. So we are going to, the way that we're actually going to try and visualize stuff is by visualizing the relationships between all these things to survive. If I'm trying to predict survive, I need to know what are the features that best give me, that best describe the data to actually predict whether I can survive or not. So that's why I'm going to try to find out all the relationships between every other column to survive, as that's my final class. So now let's actually, I've left this blank. Let's actually learn the different types of data. So let's actually take df train age. So this is numerical data. It's very obvious. Now let's look at the other ones. This is categorical data. So essentially it is, if you are familiar with R programming, I think this is called factors. Essentially this is categorical data set. Now what are the other ones? So name. So this is a string, obviously. This is not categorical. This is not categorical data. Categorical data actually has a limited set of categories. This is text data. It actually is strings. So these are actually different string names. And then what else do we have? I think we have something called cabin. Yeah. So this is okay. Cabin. Is this categorical or numerical? How do I find that out? So let's actually do value counts. Okay, there are a limited set of cabins, but there are so many cabins on the Titanic ship that I mean I can classify it as categorical data essentially, because it's not numerical. It's not giving me, okay, the cabin number might be numerical, 1 2 3 4 5 6 7 8 blah blah. Cabin number can be numerical, but essentially the whole thing, C25, that's like the cabin, the room, the name of the room. So actually, that's a good point. Someone asked me a question about type and D types. The way you actually quickly glance over all the different data types is just by saying D types. Now you see, immediately I know that passenger ID, survived, P class, they're all integers, as you can see here, 3, 1, 3, 0, 1, 1, 2, 3. And then objects. Objects are nothing but strings or categorical data sets. Float is nothing but the age. So we'll deal with those decimal age later, but essentially this D type actually tells me the type of each data set, object and float. Now, type is finding out the type of each individual one. So type of 1, this is nothing but an integer. Type of hello, this is a string. So that's type. Type means it will actually get you the data type of each individual, whatever you input. D type is nothing but the data type for all the columns at one glance. Now let's move on to the next one. Now actually let's start visualizing our actual data set. So now I hope that answered the questions how to show all outputs. So basically time to visualize the data. So the reason I'm sticking to Seaborn is because of this. All I said was count plot. Count plot is similar to histogram. It's going to count the number. The data is nothing but df train. X is nothing but survived. So the X value, I am saying pick the survived column from the data, put the hue as survived. Hue means the coloring scheme. So the coloring scheme is determined by this data. So when I said hue survived, all this is doing is using the survived column and mapping zeros to the blue color and 1 to the orange color or the light orange color. So that's why I personally like Seaborn much better. So essentially you just provide the data, the values that you want to plot, and then the hue. Now I can clearly see that there fewer people survived and more people didn't survive. So that's sort of giving me an idea that, okay, there's a class imbalance, I have to deal with that. The way you deal with this is either you increase this artificially or you decrease the number of people who died. Those are two techniques to actually solve this. Or you can just keep it as it is. It doesn't matter. You just keep it as it is and make sure that you use something called stratified sampling. I think scikit-learn already takes care of that for you. It just makes sure that the ratio of the train and test data sets is the ratio of the classes within the train and test data set remain the same. That's what it's making sure of. Now let's actually check the relationships. Someone actually at the very beginning of today's class posted that female and children survived. The male might not have survived. I watched the movie. I think some of you have watched it. In that movie also, we can clearly see that the men are actually trying to put the boats, they're actually trying to get the lifeboats, throw it in the water, and then get the female. They actually even shout in the movie, get the female and children onto the boats first, or something goes on there. So the female and children are actually sent away, and then the male are the ones. You even see the captain of the ship. He gets into his cabin, and then he just stays there until the ship sinks. So all that, you can actually clearly visualize this. I don't even need to watch the movie. I can clearly see that the way I read this histogram is the male haven't survived that much as compared to the female. Now, why do I need to know this? This actually helps the machine learning model clearly classify it. This feature is so good that it's such a clear-cut differentiation. The machine learning model clearly knows that looking at the sex category is actually helping me in giving my predictions. Without using machine learning, just by looking at this graph, I can actually create a model that will actually work very well. I think 70%, it might give me 60-70% accuracy or something. All I can say is if it's male, prediction is 0. If it's female, prediction is 1. That's it. Try it out. I'm sure you'll get a very good model. So you don't even need machine learning over there. It's just a simple prediction of just by looking at this one. So wherever it is male, obviously you will hit all these right. Wherever it is female, you will hit all these are right. And your model will start working well. So that's one reason to look at these visualizations. Now let's look at P class. assume that you actually don't even know what this P class is. Just for now, just assume that you don't even know what this P class is. P class is basically, it's telling me the passenger class. So I can guess that P means passenger, class means class, so passenger class. In Titanic, when they got into the ship, when they got onto the ship, people have been separated into different classes. So the higher class people, the middle class people, the lower class people. That's how they actually clearly showed it in that movie, and that's what we are trying to look at. From this graph, I don't know what is P class, but I know something is going on with class 3. There is a clear cut sharp spike here that tells me people from class 3 didn't survive as compared to people from class 1 and 2. That gets me thinking, what's going on? Why? What is P? What is P class? What does it mean? Maybe my intuition is, since passenger class has something to do with the class of the passenger, let me look at the fare price. Let me look at how much each person paid. Looking at this, I can clearly see that class 3, on average, they paid about $13. People from class 2, on average, paid $20. People from class 1, on average, paid $84. Now, this is giving me some meaning. P class means it's the it's basically the it's related to the price of the ticket. People paying higher will get a better room on the ship, will get maybe on the deck of the ship some room over there. And then people in class 3, you can clearly see, even in the movie, if you recollect, they actually get to the bottom of the ship and they have those cabin rooms. Some of them, they are all bunk beds, and then all of them are stuffed into one room. Essentially, that is what this P class and fare is telling me. In terms of Python code, all I did was I did group by P class, and then I got the fare, the value of the fare column, and then I did mean. This is actually giving me the mean of these values. If you remember, all these things you have actually done in assignment 1 and assignment 2, and that's the reason that I'm building up these assignments one by one. You've actually done all this. If you recollect, I've actually asked you to do the exact same question. Find out the how many male and female are there, how many people actually, what is the average fare per P class. So all that will actually help you here. Now let's look at the age. So if you remember, in assignment 2, I asked you what is the most frequently occurring age in female and male. This is essentially that, but it was very hard to visualize this because there are so many age values. But otherwise, if I can zoom in a little bit, you can see there are certain spikes here. So where are the spikes? So, okay, before that, I want to ask a question. If you all are aware of probability distributions, what kind of distribution does this look like? Can someone answer? This actually looks like a very, very popular distribution. Normal, exactly. Okay. Yeah, this actually looks like that. If you see, if you actually see it's actually increasing in between, it's dying out on the left, it's dying out on the right, and it's such a good normal distribution. So, so Sai Kritika asked, will it also be good to look at the number of people for each class? Yeah, it can. Yes, actually, that can also be a good feature. That's how you do. So maybe, but you have to think about how it will actually add value to the model's performance. So getting back to this, if I see here, the spikes are actually here. Now, what are the spikes talking about? If you zoom in, this is telling me that people in the age 15 years to maybe 30. So basically, maybe between 18. Okay, the people on the age from 18 years to 30 years are the ones who most likely did not survive. So if you see, the survived actually says blue for 0 and orange for 1. So this is actually telling me that here people might not have, the younger people might have died very easily. And if you see here, the elder people and the much more younger. So that actually makes sense to me. It really tells me a story that female, younger children, newborns were actually prioritized for and sent into the lifeboats. Younger people actually helped them do that. This all actually is making sense to me just by looking at this data and because I've seen the movie. So this is what's happening. So line plot might actually have been better. Noha is suggesting, can we see it as 2 lines? Whatever I'm visualizing right now, it might not necessarily be the only way to do it. There are other ways to do it as well. Maybe let me just try it out. Let's try sp dot, I think it's called line plot. I'm going to say the same thing. X equal to age. Sorry, the y has to be no. How can it be a line plot? Maybe let's just try it. So data equals to df train, and then q equal to survived. You can try different kinds of visualizations. Let's actually see what's going to happen. Where is the line? Okay, I think the line has become a dot. No, what happened? Okay, let me just change it to. I'm not able to picture that properly. Okay, maybe I didn't. Okay, do we even have the data? Okay, we can try out different visualizations, but essentially, you have. I think histogram might work better. So effectively, you can try out multiple different visualizations to see. Essentially, you don't need the best visualization. You need to be able to create stories out of this visualization. That's the purpose of data visualization. You need to be able to create stories and ask questions. So I think I've left. Okay, yeah, I have left this right here. So now that you have looked at some of the data points, can you all come up with some conclusions just by looking at this visualization? Whatever conclusion you can draw, just try to come up with your own summaries of in few short words, in just very few short words. Can you come up with some kind of summaries? What have you understood just by visualizing this data? I will write it down here. You can also write it down. You just post it in the chat. What can you understand from the data? What's going on? Like, what did you understand from the features? How do they look to you? That's the kind of. It might not be the main, but one of the main. That's definitely for true. It might not be the predictor, but is one of the main predictors, or one of the most helpful. Next, if you paid a higher fare, your probability of survival is actually, yeah, Aaron also made a good point. I'll just copy whatever he typed here. Okay, this is not coming. Okay, higher fare, better survival. Age factor. Okay, after that, male with class 3 cabin survival rate was less compared to. Oh, this is also a very good observation. I haven't seen that. Male with class 3 cabin survival rate was less. So these are all the conclusions that you can come up with compared to female. Features relate to survival. Female class have a higher probability. Yeah, so P class has a good indicator. Someone said, okay. Okay, someone actually just said age is not a predictor. Okay, not a strong predictor. Okay, I'm just going to put this here. Or might be, if you actually maybe better transform it. Also, age and P class might be correlated. Okay, P class. So now, how do you actually create a story? So I keep saying story. Okay, now we have actually a good set of conclusions that we came from. I'm actually going to paste all of these here so that you can also type it in. So the way, okay, what I mean by creating a story is just using these data sets and just writing this in a much more better presentable way. That's all. That creating a story is just this. So looking at the data set, we can clearly see that female and children were prioritized for the lifeboats, and then maybe young female. Okay, on higher survival. So people in the higher classes had a better chance of survival. Now, yeah, first and second class, not much, but class 3, there was so much more of a big difference. And then passengers from class 3 had a better survival chances than passengers. Is that really the case? Oh, right. Okay. Passengers from class 3 actually survived better than class 2. That's also interesting. So P class equal to 3 might have survived better. People from P class 2. That's also a good observation. So this is a short story that you can actually create based on, I just posted this one in the chat. So this is a short story that you can actually create based on the data set. Now, what is the point of making this story? The first most important thing is, when you get the data set, these are the kinds of things that actually help answer lots of business questions. This is, okay, forget the Titanic data set. Let's say you are actually working in a company and you're doing data analysis. Answering half of these questions can actually get you you can actually derive so many insights from these questions. So essentially, helping you like basically create now once you finish the story part, the other part is, I feel like I am going to maybe use maybe in my model, maybe artificially I am going to have more weights for this particular category. There might be ways to do that, but maybe it's better if I try to focus on this one. Like, or the other way of saying it is, I am going to keep this feature. I'm not going to remove it. This is a very good feature for me. This feels like a good feature, and then okay, yeah. So this feels like a good feature, and then I'm going to keep it. But if for variables that are highly correlated, like someone said something is highly correlated, I saw it somewhere. So if they are highly correlated, you might be inclined to drop one. Let's say you have let's say you have a big data set. You have a table. You have in that data set, you have height in inches, you have height in centimeters, you have height in meters. Now, what's the point of having height in so many different metrics? Machine learning model is going to be fed unnecessary information. When you look at the correlation, you might actually get a perfect correlation. Why? Because it's just a simple conversion factor between height in inches and height in centimeters and height in meters. So there's no point of feeding all 3 different height variables. I can drop 2 and just keep 1. That's how correlation might help. So let me, since I'm actually talking about correlation, let me get to this heat map. So in the heat map, basically what is happening is essentially, okay, I'm not sure how many of you know the concept of correlation or what it is. I will send you links to actually read about it. Essentially, I think I've already talked about this long back, but correlation provides correlation allows you to understand in which direction what is the dependency of one variable against the other one. So basically, if you look at this one, it's called Pearson correlation. Basically, what it actually tells you is, it gives you a value. Based on that value, you can tell if the direction of change of one variable against the other. You can just say, let's actually look at the example, and then I think my explanation will be more clear. So all I did was I did hsb.heatmap, and then pandas data frame has a function called CORR for correlation, and then I just put it inside sp.heatmap, and then it's going to plot this. Heatmap is just a better way of visualizing stuff. So I hope you all it's a bit clear visually. So zoom in. Okay. So I sent, let me minimize this one. Okay. So what's happening here is basically this is a scale for the correlation. This is highly positively correlated. This is highly negatively correlated on the darker side. So the moment I look at this, I can clearly see that P class and fair is negatively correlated. Does that make it does make sense, right? We just saw that higher the P class, lower the fair. That's what's going on here. Negatively correlated means one variable moves up, the other variable moves down. Let's look at something else. These are the other darker ones. Survived and P class. Not that one. Sorry. Okay, this P class and survived. Okay. This also makes sense. Survived if basically the people in class 3, which is a higher number, survived less. That's what this darker thing is telling me. Let's look at some lighter numbers. What is this orange? Sibling and PR. Passenger. Okay, maybe this one. What could you explain the difference between heat map versus correlation map? So, okay, it's actually the same thing. All I'm doing, heat map is just showing this in a visually appealing way. Heat map just basically colors the value of the correlation. So if the correlation values are negative, heat map just colors it in a darker way. That's all heat map is doing. It's just a visualization tool. So where is the tie again? I keep forgetting what are these two things. Just a minute. Someone. Okay, I know siblings is number of siblings. Maybe yeah, it's the number of parents. Okay, I think so. It is the number of parents, but basically, if I see these two things, the number of siblings versus the number of where is the other one? PR. Okay, so these two are a bit positively correlated. So the orange one actually tells me that they are on the positive side. If I have, I mean, it's just telling me that if I have more siblings, wait, that's not making sense. Let me just see what these two ones are. It's just a number anyway. So basically it's okay, number of parents, children aboard, and number of siblings. Okay, so naturally I think these two have to be a bit correlated, because if there are obviously more parents, you will have more children, you will have more spouses, you will have more siblings. So that's why this is how this orange color is. That's what this orange color is actually telling me. So this orange color, since it's in the positive zone, it's actually telling me that they are a bit positively correlated. This one last example I'm going to say, so to actually help you understand correlation better. Why don't we pick something else? Okay.
So survived and fair, that means that they're doing well together. Like this is the brightest of them.
So survived and fair. Okay. So that means people who paid a higher fare are more likely to survive. That's what it's telling me. So survived is nothing. It's a categorical column. It's 1 or 0. So if the fare is higher, most likely it's 1. And that's what we've seen here. I haven't compared the fare, but essentially these two indirectly tell me about the fare. So higher P class, lower fare, higher fare, lower P class, higher survival rate. That's what this is telling me. So those are the kinds of conclusions you can get. And okay, how do you even use these conclusions? I clearly know that P class and this fare are a bit correlated. They can actually help me. So maybe if they are okay, if this is a perfect -1, maybe it's worth dropping one of them. I don't need P class. Maybe P class is totally being explained by fare, but I can't jump to those conclusions. Essentially, that's how you can use correlation. Either you can keep the variables, drop it, understand the relations between them, and just know the direction. So it's, I can send you the links later to actually read about them much better, but that's how you actually understand this heat map. So that I was looking at the so someone said I think we should only look at against the survived column. So looking against other features actually gives me these kinds of conclusions as well. It's always good to look at the other features as well, because maybe two variables, like I said, height in inches and height in centimeters, maybe they are going to come up here as two different features, and they are going to be perfectly correlated. They are going to be clear-cut white, because it's just one scaling factor between the height in inches and height in centimeters. Other than the diagonal, if I see clear white anywhere else, I might be inclined to remove it, because one feature is clearly explaining the other. Why do I need to feed both of them? to test my theory, try feeding both into the machine learning model. If you find that case, try removing one and see the model's performance. You will notice the difference right there. So now we learned all about features. How do we actually start creating them? So what you've done in assignment 2 is essentially that. So in assignment 2, you actually did create these new features. Some of them at least, age normalized, sex category or something like that. So let's actually try to do that. So pandas has a good function called pd.getDummies. So what pd.getDummies is actually doing for you is it's taking the this column, it's mapping it into the appropriate numbers. So let us actually print that out. Okay. So yeah, so basically what happened was, maybe I'll get back that one. So the way I created the new columns from the existing ones is just using the same logic as before. Take the data, take the name of the data frame, create the 2 columns that you want. One important, I'll zoom in a little bit. One important thing to see here is these 2 brackets. So previously, when you wanted to create 1 column, you just use single bracket. But if it's more than 1 column, you need to enclose. It's a list of columns. That's why you need to enclose this one inside that bracket. Once you do this, you just assign it to pd.getDummies, and then let's check the result. So if I actually say train.head. So just as a side note, head doesn't necessarily need to give you 5. You can also say 10 and you can get 10 columns, 10 rows, but I'll just leave it at the default one. So if you see this, wherever there is male, wherever there is male, it marked it as 101. It's a binary. Wherever it's female, it marked it as 10. To say that this column, this row actually has female. I no longer need this one. I can just use this. Why don't we try and plot the correlation for this one? Let me see what's going to happen. Okay, where is that male female? Okay, okay. Where is the other? Oh, where is the? Okay. Those are not numerical. Okay, fine. Yeah. A correlation diagram, you can only get. You can only get you can only get numerical values. You don't get categorical values. But now that I have plotted this, I can clearly see 2 black marks. This is such a high correlation. I think it's -1. So male is negatively correlated with female. That's obvious, right? If one is 0, other one has to be 1. If something is 1, the other one has to be 0. That's what this is telling me. So that's what happens.
And then the female is highly correlated with survived. It's giving into the.
Where did you see that? Okay, here.
Yeah.
Okay. So these are the kinds of interesting information that you can actually pull out. So if you can see survived is it. So this is a very good thing. Okay, if the features are correlated amongst them, that's okay. I can drop them. But if the fact that the survived is actually related to female, that's actually telling me that female is a very good feature here. That's I'm going to use that definitely. Now, someone else posted a question. Since male and female are highly correlated negatively, should we keep both of them or should we drop it? You can try both, but you can. I think a good way is it's just you have to keep trying out multiple things to help to better improve your model. In this case, yes, you can combine both of them instead of having 0, 1, 1, 0 separate. Instead of unnecessarily increasing my features, I could club them into one such that what you did in the assignment can come here. So you can just say 0 wherever it's male, so 1 wherever it's female. Just drop the male, right? You can just drop the male column and then that's it. So you'll get what you want. Okay, so we have actually created our first 2 new features. So one thing to remember, I haven't really explored this one, embark and cabin. Feel free to explore those things. I haven't really explored. Keep on exploring the features. Essentially, that's we have actually created our first 2 new features. Okay. So I haven't done, so the code remains the same. So it's just this is to control the size. This is 20 inches wide by 10 inches or pixels wide, and then sp dot heat map, and then df dot correlation for correlation. So let's actually just check df dot correlation, what you get without even plotting anything. So this is what you see. This is the actual correlation diagram. So I can see the numbers. Where okay, where are high values? If you all can spot out high values, yeah, see fair and then p class minus 0.5, and then there are other high values as well, minus 0.5 again. I don't see any plus 0.7 or something, but essentially, okay, yeah. So minus 0.3. So these are the kinds of things. So if you see this, yeah, okay. Now, okay, my hunch was right. Female -1 male. That's how they are highly correlated. So all I'm doing is I'm wrapping this entire all these numbers inside heat map. All heat map is doing is creating colors out of it. Just visualizing it in a colorful way. That's all heat map is doing. Okay. So we have created our features. Okay, now it's time to drop the irrelevant features. Can someone tell me what feels irrelevant here? Which one do you want me to drop? You can PR passenger ID. Okay. There is no way that the passenger ID, the passenger ID, it's just an ID, right? I don't think there's any link between passenger ID and survived. So maybe for now, let's actually try to drop it and let's include it later and see how the model changes. So that's one. SIB SP. So we haven't really checked SIB SP and survived. Why don't we check that? Where is SIB SP? The number of siblings and then survived. So it is okay. It adds some value to it. It adds some kind of value to it. Why don't we run the same code? So why don't we run the same code here for SIB SP and see what's going on? There's going to be siblings. So I'm going to say SIB. What's the name of that column? SIB capital SP. Okay. So you can code along with me. SIB capital SP and then survive. Let's see what happens. Okay. What is this telling me? If there are no siblings, most likely they didn't survive. If they had siblings, they actually survived. Oh, okay. It's an interesting thing. So okay. So when there are, is this number of siblings? Let me check. Okay, anyway, I think you all already checked it. I'm not going to check it once more. So basically, this is telling me that with 0 siblings, they actually didn't survive. So it could be the age of siblings who survived. Yeah, maybe. So basically, if there are so higher the number of siblings, it's actually less likely that they didn't survive. So that is a good feature actually. Or maybe another case is it's just that the data set has more data points where there are no siblings. Why don't we check that? So train SP dot value counts. Okay, yeah, obviously people with no siblings are much higher than people with siblings, and now that's why these counts go down. So essentially, okay. So one thing that you could do as a feature engineering step, number of siblings and spouses. I see. Okay. So basically, now what?
I think
yeah.
I can just say something. So it could be also spouses. So can we double check, like see if the people, like the women that had a husband on board, maybe they are the ones that survived in that?
How do we check that? That's such a complicated question you just
I
asked
know.
me. Okay.
Just thinking.
Okay. Okay. Let's actually try to answer the question. It's actually very. Let's see.
Because I'm thinking
So
like husbands will push their wives to get into will fight to
Okay.
get her on the boat. Maybe, I don't know.
that's a good analysis actually. So why don't we try to actually fetch married women from this data set, which is such a complicated way to filter stuff. So one way is you just use the title. Okay, I'm just going to do that. So what I'm going to do is let's use dot apply again. So name dot apply lambda x such that okay, why don't let's just use the for loop df train name. Okay, one way of now actually this is a good opportunity. One way of iterating through the data set is by using something called iter rows. So iter rows means the way to actually interpret this iter rows is this will actually give you a tuple which will send out the entire column here, the entire row, sorry, not column, the row, and then the index. So the way I'm actually going to fetch each individual column is by using this. You just say I, and then you just type the name of the column, whatever you want. So this is how you iterate through a data frame in a much better way. So I'm going to check if MRS. Usually that's how you give married woman the title, at least back when Titanic was there. So if this is there in that, what do I do? Okay, basically I'm just collecting everything, right? So okay, yeah,
Yeah, if
I
it's
could,
married, then classify
yeah.
her to as survived or not survived.
Yeah. So basically, let's actually check. So this can also be done using data frame slicing. I'm going to show it both ways. So let's actually do the first one. Survived or not. I'm just going to collect that information. So survived. Not append. What am I going to collect? I'm actually going to collect the survived thing. I'm going to correct this one. So it's just very simple to do. I got an error. Of course, I got an error. Okay. Yeah. Let's actually check it. So survived or not? Okay. This is a good time to introduce another thing. There is something called collections, which is a very good package. So collections is a good package where I can actually import something called counter. So counter is nothing but a function that will allow me to actually count stuff very easily without using for loops. I don't need to keep using for loops to get the count and do all that other stuff. So I'm just going to say counter, and then I'm going to see. Okay. So maybe your hunch was right. Married women actually did survive more than.
Good reason to get married then.
So okay, so basically that's what happened here. df.name.str.contains. So I was going to show something like this, but thank you, Leon, for sharing that code. So instead of doing for loop, let's actually do it in a much better way that Leon actually shared. Sorry, train. No. Sorry, this Zoom copying functionality. Okay. Now I have to, I think, sum up something. No, sorry. 1 minute. So basically, I can just count this, and then you just count how many are like there or not, and then you just get it. So what happened actually here is these are the pandas data frames functions that help you narrow down on these things without actually going through such a tedious for loop. So that's one way to do this. Basically, okay, we went a little bit off track. Essentially, oh, sorry, I shouldn't have deleted that. How do I do Control Z? Let me get that back. Okay. So essentially, the reason that we are doing this one is basically to actually okay, like this. Okay. So basically, the reason that we are trying to do this is to actually okay, this got stuck. Okay. So now we found out something. We actually found out that married women are maybe surviving more than people who are not women who are not married. But this is not just women. Okay, yeah, this is women obviously. Sorry. So basically, what happened here is now maybe I can use this as my feature, right? How do I actually create a feature out of this? Can somebody think of how can I actually create a feature out of this? So okay, now we went through this example. Someone came up with a good idea. We found out it was like a hypothesis. We verified the hypothesis. It is true. Obviously, married women suffer. How do I make this a feature?
Should we do like we did those male and female, like get them out as Mrs. and other types, give them 0, 1s and 0, 1s and so on? A feature extraction.
How do I do that? How would I actually do it?
Good question. I'm gonna go back to the code and find out what you
Okay.
did there.
Can we add one more column about that?
Yeah, so essentially we can add one more column. The way I would add that column is maybe I would just say 1 wherever there is a Mrs. and put 0 everywhere else. So that's kind of a distinguishing feature specifically for married women.
Okay,
One
Lambda
not
one.
encoding for titles, exactly.
Yeah.
So okay. Someone said, how do we know all the married women were traveling with their husbands? So this is really getting into exploratory data analysis. So I guess that essentially sums up like the point about actually doing exploratory data analysis. And actually, we have actually engineered a new feature right out of this. And these things can actually help you build your models. So someone actually asked me a question. How did you actually think about this question? Can you explain? I didn't see your name, whoever told me this.
The question, that's me, Noha.
How did you even come up with this question?
Because it was the CBIV was 2 types. So it's either kids or spouses. So
Okay.
then I'm thinking kids will slow you down to get survived. Probably spouses will fight for their women to get on board. So that's how I thought about it. But
yeah, so essentially you have to like these questions come up naturally as you keep exploring the data. Now we have actually engineered a new basically we have engineered some new kind of I guess some kind of a feature. So someone was asking me what false means. So if you look at this thing, this code actually says name.str.contains MRS. This means 762. Okay, there are basically 129 married women. That's what this means. Now, out of this 129, I guess if you add this up, you have to get that right. Is it not? 15, 12. There's 125. Guess I'm missing something. Effectively, like this is just the out of these 129, we actually selected what we wanted over there. So basically, let's actually engineer a feature out of this. So let me get maybe put it somewhere else so that you can just write down this code along with me. How do I get a feature out of this? Maybe let's say I'm going to 1 and 0 might be so one thing we could do, if you remember the assignment, is
group by the name match between the MRS and MR.
So yeah, if you remember the assignment, you can actually fetch. I asked you to actually write a regular expression to fetch the title. So you can actually use that here. The way you could use that is you could just fetch the title and create a new column called titles. So maybe let me get that. Okay, let's instead of copy, let me just write the regular expression. So
the Findale one that you did last time.
Yes, the dictionary one, the first assignment, the last question in the first assignment. So basically it's the name. Let's actually extract the title. So dot apply such that I have to actually import the RE library first. So this is a good thing. We are actually creating a new feature right here. So let me get back to the code. So here I'm going to say re dot find all. So without this, let me just let me just do re.findAll first. Okay, so re.findAll. What is my regular expression? So I'm trying to capture the. Let me look at the title first. So when you're designing regular expressions, always keep that thing in front of you. So there are few words. There is a dot. Okay, I'm going to use that. So any capital or small letters. This is this is going to extract any capital or small letters followed by a dot, comma x. Okay, I made some mistake. Sorry. Find all. Oh, sorry. This thing shouldn't be there. Okay. I made a mistake. I only extracted the R and RS from here. So all I have to do is put a star. Exactly. Someone put plus. Yes. So I have to just put a plus over here or star. It doesn't matter. So now I fetch the titles. So now let me fetch that the actual one of 0. Okay, so I actually extracted the titles. Now I'm going to say df train titles. Titles. And then I'm just going to assign it to this. This is how I create a new feature. And then let's actually look at the data frame. So sorry, I couldn't answer a few questions. It went by. I guess Leon is answering them anyway. So if you look at this, the titles have actually extracted them. Why don't we try to do pd.dummies over here? So pandas get dummies. So what do you think is going to happen? Get dummies. So now if I do pandas.get dummies, let's actually see. Okay, you see that I actually got 17 columns. What happened was wherever there's a Mr. it's a 1, wherever there's a Mrs. it's a 0. This is okay, but it's not that great. It's such a huge sparse matrix. Like it's such a huge sparse matrix. All these are zeros. It's totally unnecessary. I can grab any one of these columns. Which one? My hunch or my inclination is that I want to grab the Mrs. column somehow because we just arrived at some good conclusion. So let's maybe get the Mrs. column and then use that as a feature. So that's all. We've actually engineered a new feature that actually focuses more on Mrs. This is how you actually create new features. One way of creating features. I didn't plan for this. Noha directly asked this question. It came out of it. So this is not pre-planned.
Sorry for your trouble.
No, I'm saying this is a good thing. It's a good that it came out naturally. So now that we've engineered some feature, I hope you are getting the idea of how to actually create some new features out of this. So the name might not mean anything, but the title definitely means. Why don't we look at doctor? So someone actually in the beginning of the, so this is the last thing. I'm going way off track, but actually it's not off track. This is feature engineering. So let's stick to this. So let's actually look at how doctor is actually related. So okay, let's actually look at the title and survived. Why don't we look at that? So let me just do correlation of this thing. So let me get okay. So correlation might not be better. I want to check the doctor. Okay, I think we can just check the doctors over here. So TR. Okay, let me check this here. Okay, 4 and 3. Oh, are there so few doctors on board? Okay, okay, I say there are so few doctors. I say okay. Okay, I say let me get the titles. Yeah, right. There are just 7 doctors. So most of them are Mr. and Mrs. And obviously that does make sense. So why don't we look at number of parents here? Okay. So this is telling me that I see. Okay, number of parents. Okay. Yeah. So these are the kinds of things that you can again engineer new features from this, right? From these visualizations. So that is why I think I'll stop here. So doctors are most likely men. doctors, we can't come to that conclusion yet, but in though actually you might be right. When Titanic ship was there at that time, in that period, in that era, doctors were most likely men. If you look at the stats and the numbers, they might have been. That might be the case in that era. So I think we'll stop here with the feature engineering. We actually did a lot. People are getting excited and throwing out more comments. Feel free to actually build new features like this. So once you actually, now that you all actually have got into the mindset of feature engineering and exploratory data analysis, let's actually get the model. Okay, for now, let's actually look at where we are in the data set. Okay, we have titles, we have this one, we have this. I'll consider the titles a bit later. Let me just run the machine learning model and then we'll come back to counting the titles. So what else do I drop? Cabin, get ticket. Passenger ID. Okay, everything else is the name. What else? Fare, cabin. Okay, let me drop cabin also for now. Embarked, let it be there. Embarked is actually S and C. Let's actually check if we can keep embarked or not. How many are there? I am purposely doing this live because this is how you can nicely analyze this data. Okay, it's just 3-1. So let me just do pd.dummies again. So this is okay. There are multiple ways. There are packages called label encoders and one-hot encodings. You can do that, but for now, let's stick to this one. So I'm going to say df train let me just get the Q. pd dot get dummies df train embarked. Okay, so you don't need to do this always. There are better ways to do this. You don't need to keep. What if there are 50? You can't keep typing 50. There are better ways to do this. I can show it to you later, but essentially it's the easiest way for now. So let's look at df train now. Okay. Okay, I got my SCQ, so I'm going to drop embarked as well. And what else is there? Let's actually drop these things and see what happens. Drop features. So what I'm doing here is I'm saying dot drop, and then I'm saying in place equal to true. What this actually means is, if I say in place equal to true, I again don't need to keep doing this. I don't need to say df underscore train equals df underscore train dot drop. If I just say in place equal to true, it happens in place. You will get an error if you run this. I think, is that what you all are posting about? Showing wrong values. Why? All right. Okay. I guess this is okay. I guess this is the right one. No. Okay, let me see how this actually got printed. Okay, the C, Q, and S. Okay. Okay.
Does it matter the order of them?
Yeah, it matters. Right now, you see this symbol is wrong, right? I mean, it does matter, because if this embarked feature says S, and then this is actually pointing out to, like, the machine learning model can actually learn the wrong thing. That's what I'm trying to say. Now you get, I think you got the right one. So yes, it does matter because for this particular row, 100 means something to the model, and 010 means something else to the model. So that's why. Okay, now we are dropping these things. Df.drop. So I think you'll get an error if you run this, because one thing to actually specify here is the axis. So the default axis is 0. So what I mean by axis is, axis equal to 0 parameter, it means you're dropping the rows. Axis equal to 1 means you're dropping the columns. So I'm going to say equal to 1. Now we have dropped it, and then let's check our data frame. Okay, So it's looking good. Okay, I have to drop this one also. I forgot. Okay. Okay. Just we already extracted the features from it. Access equal to 1, place equal to true. Okay, you can't run these statements again because it will throw an error. You already dropped it. So this is great. I have P class, I have age, this one. Okay, this is fine. Let's actually try to run it and then do our modifications. So
Could I
this
ask
is
a question?
the prepared data set. Someone has a question?
Yeah. Could you explain the significance of access when we are giving column IDs here? We just dropping all the columns that are mentioned here, right? So what is the significance of saying access is equal to 0?
Oh, that one. Okay. So if I say access equal to 0, I am instructing data, the pandas data frame to remove the rows. If I say access equal to 1, I am specifically instructing pandas to say I'm going to remove columns. Be prepared for that. That's what's going on. So without specifying this, pandas is going to assume these are row names. But for us, these are actually column names. That's why.
Yeah, thanks.
Okay. Okay, so basically now that we've prepared our data set nicely and neatly and we got some features, we drop the titles, we'll get that back. So let's actually try to just do this for now. So this is the most important thing. We need the survived column. Without that, we can't make any prediction. So I'm going to do train test split, df underscore train. So how do I select everything without survived? Can somebody write the code and paste it in the chat? In one line, I want you to select everything except the survived, because obviously you shouldn't split it in that way. You can try it out. I want you to select all the columns except the survived column. Okay. The simplest answer is drop survived, but I can't drop survived. I need that survived. How do I store it somewhere else? Okay. So this is how you can do it. I mean, simplest thing to do is just, yeah, you can drop survived. You can say, so you can take dot loc, all the rows, all the columns from P class. Okay, you see I dropped, I removed survived actually. You can do that also. So for, okay, in my case, survived is actually the first column. That's why I think actually what Crystal said is also right. You have to do in that way. You have to do ILOC 1 comma, and this is LOC is using the name of the columns. So I'm going to take this, put it here. Your answers are also right, whatever Crystal and posted in the chat. df.survived, that's the most easiest thing. So basically I'm going to say df underscore train dot survived. Okay, so now that I got my survived, I got everything except survived. My test data set, let me split it into 20%, is not defined. Okay, I haven't imported this. You have to import that from sk, where is it? I forgot. Train test split, I think it's there in metrics. No, where is it?
Pre-processing.
Is it right? Okay, let me check. From Scalar pre-processing import. No, no, it's actually, let me check. Okay, this is a good point to show you what you need to do. You just go here, just say model selection. Right, that's right, model selection. You're right. I just forgot that. Import train test split. Okay, now you got the train test split. Go down and then yeah, you just run this function. So now let's actually look at xtrain, xtest, ytrain, ytest, xtrain. Okay, you got all the data here. You see that you only have 712, and then you see xtest, you only have 179, and then you see ytrain and ytest, and then white rain. Okay, so I guess some of you might had this question, but what we did might not actually be the right way of doing machine learning. Let's try to finish this and I'll explain what's going wrong. If someone can figure out that, that's great. We actually went through a process which had a bit of a flaw. If you can figure that out, post it in the chat. Otherwise, I'll tell you what that is. So essentially, let's actually try to run logistic regression. So I've defined this. I have to provide the strain, and then the flaw is related to the data. So maybe you can think about that. Not scaling. It's sort of related to something called data leakage. I'll tell you. Y_train2. Okay, so missing data. Actually, you're right. I think that will be a problem right here. Okay, now you see the issue of this missing values. So machine learning models, they can't take missing values. So let's actually drop the NAs. So dealing with missing values. So I will send you a blog post, which is very good. They actually dedicate an entire blog post just to talk about how to deal with various types of missing values. So let's actually first check what are the missing values. Okay, only age has missing values. Okay, fine. So what do we do about this age? Does anyone have any ideas? I'm straight away going to replace it with the most frequently used age. That's what I feel is the best bet, because age is an integer. You can't have decimal ages. Replace based on other data. Yeah, you can do that. So why don't we try that? So there is a nice function called fill NA, and then the value. So you can just say method equal to I think bfill is one method, backfill. Okay, so the age value has been filled. If you check is null dot sum, yeah, there are no missing values. So let's actually use in place equal to true. So if I say in place equal to true, it's going to change that. Now let's check. Okay, this should have actually run before. Sorry, this should have actually run here. So let me put it at the top. So let me write it here, missing values. Now let's split it, delete this one, then run this. Okay, total number of iterations, limit convergence. What happened? Okay, let's actually see our predictions. I need to also predict, right? Where is the, I need to get my predictions. Titanic model V1. Just call it, you can call it whatever you want, but I'm just calling it V1 because when you have more complex models, you can keep track of these things. Predict X test 2. Let's see. Oh, sorry, it's called Y test 2. I don't know why I called it like that. Let me print this and see what happened with all our new features. Oh, it's actually working well. It's actually working so well, right? If you remember last time, I had to put weights and I had to guess those weights, blah, blah. I had to do so many things. Right now, if you see, the model actually performed so well. Our engineered features actually work well. So you can actually really see the effect of feature engineering on this model. If you remember the first one, I think I still have it somewhere. It was so bad here. The predictions and everything, it was totally zero. I didn't even put anything related to regularization. I didn't do any class weights. I have done nothing. I just engineered few features and built my model, and I have such good results right here. I'm saying it's such good results because the precision recall and F1 scores all are good and the accuracy is also good, even though the data set is a bit imbalanced. Now, what we have to do is actually test it on the test set. So let's fetch that one. Yes, data set. pd.read csv. Can you show the method you use for filling missing values? Okay. This is what I did. I just did. This is a pandas data frame function that's called fill na, and then I did method backfill. There are other methods as well. You just need to hover over this one for just 1 second. And you see backfill, bfill, pad, ffill. There are many methods. You can also use your own methods. Replace it with the mode mean. I mean, for age, mean doesn't make sense. Mode makes sense because you can't have decimal ages unless you're counting the months also. But otherwise, this is the method. So I can paste it right here in the chat. Okay, so let's actually get the test. Okay. Can you give me your yes or no answer? What will happen if I feed, okay, can I feed this data as it is to this predict function? Can I just say df underscore test dot predict test, like just the whole thing as it is? Yeah, the reason is the model has been trained on this data set. You can't feed this data set. You have to transform the test data into this one. Let's actually try to do that. How do we do that? This is the problem. So I have to go over all these same steps, whatever I did here. So what did I do? I have to go over all these steps again. So I did so many cleaning things. I have to have a record of all. So this is what I'm saying. There is a much better way of doing this. We should do feature engineering again. The more efficient way of doing this is something called pipelines. So scikit-learn provides, or in general, you define these pipelines much ahead. You pass. So when you're doing feature engineering, you define these pipelines, save the pipeline. Once you get the test data set, all you need to do is pass your data through that pipeline, and all these feature engineering steps will take place, and you'll just get your get the output like this exactly. That's the purpose of pipelines. You need to do the feature engineering again, but in this way right here, what I need to do is I need to manually go through everything what I did. So I guess I need to do this pd.dummies thing. I need to do male, female. I need to replace age and blah. I need to do so many things. So once you all do that, try to do it. Once you do that, run your model using this entire data and then compare it. Okay, survived is not given. What you need to do is, okay, let me actually do it right here so that you can actually make your first ever. I mean, if you participated in Kaggle before, that's great, but otherwise, your first ever Titanic dataset Kaggle submission, let's actually try to do it. So we have to do feature engineering again. So what did I do? I guess pd.get dummies. I have to keep doing those things. So let's get the code. Same thing here. So I'm doing a copy paste for your practice sake. Do not do that. It's a good practice to not copy stuff and actually write from scratch. So test. Let me say another one. Test of. Guess what was the second one? CQS. Okay, CQS. pd.get dummies. F underscore test. I have to do this feature engineering once more. What was that? I forgot. Oh, this was the embarked, right? Okay. Embarked. After this, what did we do? We dropped all these features. Okay, fine. I have to do the same thing. Okay, let me just fetch that.
Just copy it. Don't worry about it. No judgment here.
Okay.
Take your time, don't
Copy.
worry about it.
So let's actually, thanks for the motivation. Let's actually drop the features. Let me include that one that I missed here. So drop get test. So I hope I have done everything right. Access equal to 1. So this one, okay, we got this, we got male and female, we got fair. Okay, the missing values, we need to check for the missing values actually. So let's see if I had TF underscore test. I mean, there shouldn't be any missing values. Okay, there are missing values. Okay, cabin age. Okay, age is again. Let's actually use the exact same method that we used for the train. This is not data leakage. Data leakage is something else. I'll cover that later. So data leakage basically means looking ahead into the answers without actually looking ahead. So basically data leakage means so basically data leakage means data leakage means you engineered your features based on the test data, which you are not supposed to see. That's the whole thing about data leakage. So if you remember the let's say the standard scalar, or maybe the one-hot encoding, whenever you do fit transform, you have to only do the transform, the fit part on the train data only. Then you should do the transform part on the test data. You should never do fit on the test data, because that would be cheating. That would be looking ahead without when you shouldn't be looking. That's called data leakage. Data leakage means looking into the test data set and biasing your model based on the test data set. That will be bad because you don't know the actual test data set. Okay, now I know how the test data set looks like, but in reality you never know how this actually looks like. So that's why data leakage is something you have to avoid. I think I got everything. Let's drop this one. Let me just run this. Title is not found. Okay, why do I need title? I didn't even create it. Okay, so we got everything. I guess let's look at the test data. TF test. P class, age, CSP, parts, fair, female. Okay, I have everything. Now let's actually see what's going to happen. So Titanic model dot predict TF underscore test. I'm just going to give it as it is. Just going to give me. Okay, why are there nans? I just dropped everything. Oh, the age. No, I filled the age. What happened? How is that possible? Really? What is that? Let me check. So basically, you can check it in this way quickly. Age dot is null equal to true. Is it still 10? Okay. Let me just replace. Let me run this thing again. Isn't it getting filled? Okay, something is going on here. Okay. It's a variable name, right? Okay. Let's just okay, this shouldn't happen.
Can you just drop those two?
Okay. No. You're not supposed to drop these things because Kaggle actually expects you to give the answers for all the values. This is the test data set. You're not supposed to drop anything. I mean, you can drop it, but actually, I think you can drop it anyway. But Kaggle anyway, it will just check whatever you have. You'll just get a lower accuracy score. That's all. Yeah. Okay, let's actually drop it and see what happens for now. Df test dot drop age.
Because why is the fill option is not working for these two rows?
Yeah, even I'm not sure actually. It's the first time I'm seeing it. Maybe okay. Let's investigate that later. Let's actually try to drop this and get that Kaggle submission file. So drop. Okay, shouldn't drop it like this. Let me say index number 416, 417, axis equal to 0, in place equal to true. Okay, this is how you drop indices. So now let's actually check. don't think you're supposed to drop stuff in the test data, but
Only
can.
why you are using that x is equals to 0 and x is equals to 1. Could you please explain that? I did not understand that.
So axis equal to 0. So did you just see what I did? I actually used axis equal to 0 to drop the rows. When I use axis equal to 1, that means I am dropping the columns. So I am instructing pandas data frame and I'm telling pandas specifically to drop the columns. Pandas is going to assume that these are column names. If I don't provide axis equal to 1, try to run it. Do not provide axis equal to 1 and still try to drop it. What's going to happen is, I'll show you. Let's actually try to drop the fair. Nothing is going to happen. Fair not found in axis. That means it did not find anything called fair in the rows. That's why.
Oh, okay. Okay. Thank you.
Okay. So now that we have, let's actually try to predict Titanic model. Dot predict. Okay. What is that? df underscore test. Okay, I got my prediction. I can't do any classification report. I don't have the labels. How do you actually save this and submit it to Kaggle? Let's actually look at the where is the gender? Okay, the gender submission.csv is the way you actually submit it. That's why they gave this sample. So let's check how that is. The gender submission. They need the passenger ID. Okay. So this is how Kaggle evaluates it. You need to give you need to provide the passenger ID and the survived or not, and then finally you can submit it to Kaggle. So how do you get the passenger ID? Is it there already? Okay, we actually dropped the passenger ID. Okay. You shouldn't be dropping the passenger ID. That was a mistake. Let me run it once more. So basically, Kaggle expects you to provide it in this format, passenger ID and survived. So let's actually get it once more. Is null. Let me run this whole thing. So don't drop the passenger ID. You need that. Drop. Okay. Now, when you're actually predicting it, don't use the passenger ID. That's all you need to do, because obviously the model is not trained on the passenger ID. So let's see. Okay, this is still happening. Okay.
Yeah.
Okay, something is going on there. I need to investigate that. Maybe I'm doing some mistake, but otherwise, let's drop that.
It was 416 and 417, I think.
Yeah. Someone posted a solution. We can try that once we finish this. 416, 417. In place equal to 2. Notice that I actually won't put axis here because the default is 0. It's going to automatically drop that. Now is null dot sum. Okay, so is null dot sum. I guess we don't have anything. Now let's look at the df test. Okay, we have the passenger IDs. Now I'm going to try to run it and see what happens. This is going to say X has 11 features, expecting 10. That's what happened. So it didn't expect passenger ID. So let's actually do that. LOC, all the rows, select from P class until the end, and then make a prediction. Now, what you need to do is store this somewhere. This is my predictions for submission. So now what I'm going to do is, this is how I'm going to create a new CSV file. So let's say, let's actually say, let me look at this predictions for submission. This is an array. I need the passenger ID. Okay. So let df submission. So I am going to grab the passenger ID from this dot copy. I don't want to mess up the original one. So submission passenger ID, put 2 brackets here. Now Now all you need to do is just say df submission survived. The problem is I don't think this will work because this will work. Yeah. Okay. Predictions for submission. Okay. So let's look at our submission. Okay, we have it exactly as they wanted. Now all you need to do is
Compare.
no, you can't compare. Like this is a sample submission actually. This is just to show you what it looks like, but this is not the actual submission. So basically you have to actually save it as a CSV file. So you say .csv. What did they ask me? Let's go to the Kaggle thing. So what did they ask me? Submit prediction, my submissions. I guess I don't have any. Let me see, how do I submit it? We also include a set of predictions that assume only all and only female passengers survive. As in, okay, you see, okay, this is a sample submission. I guess let me just submit my prediction. Okay, let me actually make a submission. I have 10 submissions remaining today. Okay, so let me see. So the way you save it is, I'm going to say submission underscore v1. Okay, dot csv. Okay, let me see what happens. It will come here, right here. Let me refresh this. Okay, you see submission underscore v1 is right here. I'm going to download this file. Let me put it in week 3. Let me go to Kaggle. You all can follow along with me. Let me just upload that file here. So week 3 submission. I hope this will work. Okay. Step 2, describe. Briefly describe. Okay. Okay, what should I write? I have used the logistic regression model to make my predictions. I have explored the data and engineered some features. Okay, let's see what happens. Unexpected column. Oh, something. Okay. Let's actually check this submission.v1. I think one extra column got added somewhere in that CSV file. So when you save it to a CSV, you actually open it and check. You will see one empty column unnecessarily gets added. Just remove that one. I didn't save it properly, but essentially this is how you actually. So this is how you can actually measure progress in your models. Right now, my model is working fine. It's working well. I engineered some features to make to. This is just 84%. There are people who made submissions that went up to 96% as well. To get those kinds of accuracies, obviously we have to get for better models, or you can stick to logistic regression and actually add more features. So okay, this is taking long. In the during while this opens, if you have any questions, you can post, or if someone already made their submission, you can post your result in the chat. Just taking some time to open. Okay, essentially this is how you make the submissions, and then maybe some of you can form a team and then work on this and get a good pattern prediction survival, and can be good teamwork as well. Okay, this is taking a long time. Okay. Did someone already make a submission? Are you going to post the uploaded? Yes, I will post the notebook in collab file to the drive. Okay. Since I made a lot of changes, I'll clean it up a little bit, add some explanations, and then post it. So just to answer everyone's question. Okay. While that Excel file loads, I don't know when it's going to load. Okay. Yeah, it's here. Okay, yeah, this was the unnecessary column. So just delete that thing, save it. And now let's get to actually uploading this file here. Why is he asking me for explanation again? I just wrote it. statistic regression model. Okay, yeah, that's why I could not have dropped that. I
It's
shouldn't have
upset.
dropped. This is why I shouldn't have dropped that. So okay.
Okay, if you just quick, probably at the end,
I-
I was looking at searching it up. As they were saying, maybe you can use, instead of backfill, you can use forward fill. That
Yeah,
might
you
help.
can essentially. Like I think the backfill didn't work because it was the last set of rows, but essentially, just want to make one submission during the class, and we'll see how it goes. Let me just, okay, this is the last one. After this, we have 10 more minutes, so I have to cover just one more topic, that's advanced feature engineering. We'll definitely cover that today after we finish this Kaggle submission. I guess no. Oh, thank God. Okay, everything is fine. Let's just run this predictions submission. This one. We have to open that and remove that unnecessary thing. Okay, this is fine. How many rows
Can you
are
double
there?
check it's 418 at the end?
Okay, no, I didn't download it. Please, okay. Let's open this one. How many are there? Okay, 419. I think yeah, there
that
are
works.
419. Okay. Okay, so let's actually make this submission and see what happens. File submit. Something tells me this isn't your first CSV file. Wow, Kaggle is, oh my God. 75%. Okay, that's not bad. Like at least 75% is not bad. Like this is the test. This is my competition submission. If you all can beat this and get form teams amongst yourself and get a better result, that's good. So let's actually check the leaderboard. Obviously, I'll be somewhere in the bottom. But otherwise, okay. You see these guys? They got. How did they get a perfect score? How can that happen? Okay. Okay, they made a perfect score somehow, which is great. We are somewhere here. 75. Where am I? Okay, yeah, I'm somewhere here. 45,000 something. We'll get there. Obviously, we'll get there with much more complex models, but that's the whole. That's actually how you do Kaggle submission. So now you all can make your submission as well. Just save it as a CSV file and upload that one, and they'll actually score your predictions. Let me close this. Okay, so now looking at advanced feature selection techniques. So until this point, we actually explored up to one level. Our model is performing very well. Now you see that this is not always a great predictor of your final result. I see 84 here, but when I actually submit it on the test data, it's 75. So there is so much room to improve, like 25% room of improvement. That's what you need to do for feature engineering and building maybe neural network models and all that other stuff, which is what we will do in the next 2 weeks. So how do you do advanced feature engineering? So as I said, there are multiple different techniques. Today, we are going to stick to select k-best. I actually didn't do anything here because I wanted to show you, if you are someone who's very new to machine learning, how do you even go about searching them online and getting the right results and actually using, how do you even know how to begin with? This is what I would do. You just go here, open a new tab, just say sklearn, select k-best, and then get into sklearn and then read about this. You'll actually understand what's going on inside select k-best. So they have all the documentation, parameters, and everything ready. Essentially, what select k-best is doing is it's running one of these statistical tests, chi-square test, ANOVA. What is that? There are other tests as well. Mutual information. It's gathering all those scores, and then for those features that cross a minimum threshold, for those who study statistics, I guess you know this hypothesis testing, p-values, and all that, all those concepts. It's basically using those things, setting those thresholds, and then selecting features based on those thresholds. This is not feature extraction. This is feature selection. So a subset of the features. How do you use that? They even give you examples. This is why sklearn is such a very popular package. They actually give you such good examples, and then they show you the result, and they show you actual working examples, full-fledged working examples with complete code. So you can always learn lots and lots of things from sklearn website itself, scikit-learn, I mean. So let's actually try that. So what did they say? For my sklearn.feature selection, get select k-best. So if you just want to try it out, you don't even need to go to scikit-learn. So let's feature selection. Select k-best. I think I already selected it, but let's do that. You don't even need to go there. Google Colab will actually provide all the documentation right here. So I'm just going to fetch this whole thing. No, I've already imported it. I also need, let's start with the chi-square test. Okay. Okay. What is it going to do? First of all, we have to check how many columns we have. So df_train.shape. I think we have, how many do we have?
11.
11. Okay, 11. So maybe, okay, I'll start with 5. Let's just try to fetch 5 out of them. 16. I think this should not work actually. I think so. Oh, this worked. So what happened? It actually fetched me only 5 features. The select k-best algorithm based on the chi-square test decided that the 5 best features that algorithm thinks is the best is these 5 features. How do you get the feature names? It should be there here. Get params. No. P-value score function. I think there is a way to, okay, inverse, no, inverse transform, or I think there is a way, but basically essentially these are the 5 features that I got. This is my new data set. So this was my original data set. Let me check that. This was the original data set. Out of all these columns, basically it decided that I only need to keep them. I think it kept the P class, the fair, the female male thing, and then I guess it kept one more. So basically select k-best uses statistical tests on each individual column, gives them some threshold values, and if the column values are beyond threshold values, beyond certain threshold values, it just selects them and keeps them, and then you can build your new model based on this. It will take a lot of time to actually deep dive into how it actually does feature selection. So there are techniques known as forward not getting the names right. Backward minute. It's called forward feature selection. Okay, SFS, yeah. Okay, this one, yeah, this is what I was talking about. So the methods that it actually uses on the back end, it will take a lot of time to actually get into this. Yeah, this is what I was going to get at. Sequential feature selection. It will take a lot of time to explain this, but in short, what sequential feature selection does is it's an entire algorithm that's designed to select features. So the way the algorithm is designed is sequential feature selection. There are 2 ways of thinking about it. Either take the entire data set, then cut it down, chop it down one by one, and see if, let's say you remove feature A, what is the score? If you remove feature AB, what is the score? By score, I mean how good is the data set. So the score is the goodness of the data set. Sequential feature selection is a technique where you actually, it greedily, iteratively finds the best new feature. So it has an empty set and it keeps adding features, the best features. So it's like it's such a huge process that it has to select every combination of all the features. Backward feature selection is like the reverse. It takes every it's instead of starting with no feature, it actually starts with all the features and then greedily removes everything. So these are the two techniques that go behind not this one. It's called recursive feature elimination. This method. So recursive feature elimination basically involves these things. So this is why scikit-learn website is one good resource where you can actually learn about all these algorithms. So another feature engineering. Okay, I think this time's up. So last thing I want to mention is another feature engineering step that I have not talked about today is the age. If you remember, the age was decimal values, which doesn't make sense. So one thing is either you could remove those values completely during training, or keep those values, just convert them to integers. Maybe if you remember, the minimum age value was 0.42. You could just, maybe someone in an error made a mistake saying that instead of writing 42-year-old, they just put 0.42 by mistake. So you could convert that to integer. These are just guesses. So there are different ways to deal with this, but these are just one idea. Okay, I think we have right on the dot. Thank you for attending week 3, and I'll provide the new cleaned up version of this notebook soon, either today or tomorrow, and also the assignment for the next week. I can stay for 5 more minutes. Otherwise, if you have any questions, I can take them now, or else I think we are done for today.
Thank you for your patience today. And going sideways. Thank
No
you very much.
problem.
Thank you, Ani.
Had a question.
Yeah.
What is a sparse matrix or a sparse data set? I don't know exactly what that is. I come across that in the documentation quite often.
Can you say that again?
Something to
Maybe
do with sparse.
Sparse matrix. Okay. If you remember that Mr. Mrs. The Mr. Mrs. PD dummies that we did, you got a huge matrix of all zeros, right? Zeros and ones. Like it was completely zero, and wherever there was a Mr., it was a 1. That's a sparse matrix. Sparse matrix is nothing but it's an empty matrix. It's all filled with zeros except data at some point. So if I show you an example, we have it. Okay, we don't. Yeah. So okay, I guess that's gone somewhere. Okay, essentially a sparse matrix is nothing but a matrix with okay, I can consider this one maybe slightly sparse. It has many zeros everywhere and just ones at some point or the other. If I take this whole thing as one matrix, sparse matrix is nothing but a matrix which has all zeros, lots of zeros and few ones, few values.
Hey, Annie, can you please go back to when you split the train and test data? It's just like, please.
Which one?
When you try to split the test and train data.
Yeah, this step.
Yeah, please.
Okay, so okay, all here, what's going on is train test split is a function that actually just basically splits the data and it creates a tuple of 4 variables. The first variable is xtrain, xtest, and then ytrain and ytest. So you just need to input the x values, all the features except the survived column, and then the survived column, because the survived is what we actually want to predict. So you put all the features here, and then you put the survived column here, and then you say test size 20 at 0.2. It means 20%. So 20% of the data is reserved for testing, and then the rest of the data comes here, xtrain.
Again,
it's
please.
Sorry?
Yeah, can you explain again, please?
Okay, what is happening here is basically this data set is being split into 2 parts. The first part is called train. That's coming right here, xtrain. So I'm taking all these 891 rows and I'm taking 80% of them. So 0.2 actually means 20%. So 100 minus 20 is 80. So I'm taking 80% of 891. So that's roughly 64, maybe roughly 700. So roughly 700 rows are being split into this one, are being dumped into this one, and then the rest of the 20%, which is roughly 900. Okay, that's roughly 180. 180 rows are coming here. So it's just divided into two parts. That's all. Just being split into two parts. That's all this function is doing. It's just
Thank you.
chopping this entire data set. Yeah. How do you understand from the numerical values, how to know, yeah, which features are being selected? So I guess we have to explore the select k best, but the way you do that is can do inverse transform. So once you actually do this, so you have to do, when you do inverse transform, it will expect a data set that will actually do inverse transform for you. So like the sorry, not this. You have to, instead of doing dot fit here, you define. So basically, it has something to do with this thing. Let me show you the documentation. So if you see this inverse transform, reverse the transformation operation. So there is a way to actually get the parameters. I can't seem to find it here. I'll let you know in the chat anyway. There is a way to get the column names. I think it is called get features, or I'm not able to recollect it now, but I'll definitely let you know.
You want to
Yeah,
try
it's-
get support?
Okay, where did you see get support? Oh, get support from here. Okay. Yeah, so I think maybe let's try that. I shouldn't be applying it like this. Okay. Let me do it the right way. So this is how you do it. Select here best. Now you should apply it everything on this one. Once you create the object, now everything will work. If you see, okay, see, I got everything. I can do inverse transform and get back the original data set, or I can do get support. Here. Okay, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 because my DF train had 10. Now this true and false actually corresponds to, I guess, the indices, like the. Okay, so if I say this, it starts from here. So obviously I got P class. I did not get age. I did not get siblings. I did not get this, but I got fair, which I can see here. I got female, I got male, and I got the last one. So that's what happened. So essentially, I guess let's see what happens if I put it. Yeah, essentially this is get support actually gives you this entire thing. So I think if you just put it in. Okay, yeah, anyway, this is how you do it. Now to map it back to your actual ones, you can use panda slicing to actually fetch the columns. Okay, someone wanted the regular expression. So actually, I think I deleted that regular where is that? Let me check. re.find all. Okay, it's right here. Okay. So I'll just paste this in the chat. Okay. Okay. I think I'll start preparing the notebook. So after this, you have the features, then we do regular. Yeah, logistic regression. That's all. After this, you have the features and you just do logistic regression. So I think I'll stop here for today, and let's get back next week.
式。